can hear you, but you're quite quiet, and sorry, we're having a little bit of a start to the day. Let me... Okay, how do I get the audio to... Perfect. Yep. Got it. And I will talk to you later. Volume all the way up. All right. Speaker particular device, but can you hear us? Can you try to say something?
No, it's somewhere.
Okay. Just a moment. Thank you all for your patience. Ooh, that's not the happiest. Get rid of fuel screen. Oh, there we go. Hide this. Move this over here again. Okay. Hopefully, be able to hear us. And this is Zero Instrumentation Observability based on eBPF. Nikolai, I'm going to try to get the audio as best as I can for the in-room, but I believe you are streaming. Can you hear us? Can you hear you?
I can recognize.
I think you can go ahead if...
Oh, cool. Let's start. But you should mute or something because I hear myself.
You hear yourself. All right. And I should mute myself.
Start. I'm Nikolai.
I'll try to raise the volume.
Today I'm going to talk about instrumentation observability. A few words about me. I'm
Speaker.
an ops guy initially. Admin and run pretty big infrastructure. And now I work on open source observability platform and try to and already gained over 5,000 stars on GitHub, so check this out. And let's start from the very beginning. What is observability? system right now. So, and observability is being able to, how is the system performing now, and being able to compare its performance with previous periods, and why do we need the first to understand our system performance to make money. Our application can serve users, available for users, and one important mention here is that making a system observable doesn't guarantee availability, but understanding and being able to understand what was happening with our system right now can drastically. The next, that as our application more performant, we can serve users faster, and like according to many researchers, lower application latency can lead to increase in revenue. And the last one is because if your application performs better, it requires fewer computing resources, and then it can reduce your cloud bill. But or we have, let's compare. I'm a relatively old guy and working in the field when systems were much simpler. Before, like monolith applications that run on dedicated nodes was like single piece of code. They communicated with databases, and it was pretty simple and straightforward to troubleshoot them. We should check application logs and metrics. We should check underlying nodes. We should check its database necessary. Now we have, like in most cases, you have to deal with microservices, where we have a set of services that communicate with each other. Their database is most likely distributed. Everything runs on structure. You have dynamic nodes which can appear and disappear anytime. And to troubleshoot such systems, to follow the system topology. Start from the first service and check its metrics, logs. Then we check dependency services and then their databases. And it can be pretty time-consuming to understand what's happening in this distributed system. To make system observable, we need to proceed with a few steps. The first step is gather telemetry data. Telemetry data usually metrics, logs, traces, profiles. And the important things here is that to be able to see the big picture, to cover your entire infrastructure, and this can be challenging because of third-party and legacy services. And it's pretty time-consuming to manually instrument each component. Then we need to store somewhere our telemetry data. You can use cloud vendors, or use some time series databases such as Prometheus. Doesn't matter. And the last step is understanding your data. You need to understand how use all these telemetry signals to answer questions about it. And from my perspective, it's the most challenging part here. But before we will talk about eBPF and how to gather telemetry, let's understand what we want to know about our application. First, the most important part is being able to understand how each component performs right now or over time. Usually it's called service level indicators, where we know the number of requests served by an application, errors, and application latency. And the next step is to understand how our application communicates with dependency services or databases. We need to understand, again, latency, errors, number of. Then we should be able to understand resource consumption, memory, I/O, and so on. Since our services create network, we need to understand network latency, network connectivity, and other network-related possible issues, such as packet loss or packet reordering, and so on. Also, since our application run on some nodes, to understand node level metrics, their capacity, their resource usage, then runtime metrics. If our application run inside Java virtual or .time or Golang runtime, we should be able to understand what's happening, garbage collection, connection, and logging. And then we gather logs to understand application issues or understand, for example, if you run our application on Kubernetes, we should understand issues related to organization, such as available schedule pod, node, or something. Why we might need eBPF here? We can gather the majority of the data without eBPF, but it would require manual gathering metrics, discovering logs and databases. With eBPF, it can be done in minutes because it doesn't require any changes, deployment of your application to run the agent, and that's it. And it also can help us our entire infrastructure, because eBPF-based installation can cover even legacy or third-party services. And also, I would emphasize that implementation is not a one-time process, continuous process, because you, for example, a few days after you're finished your initial effort instrumenting your application, you're deploying new component, and it also should be covered by observability. And let's talk about just a quick intro in eBPF. eBPF is a feature of Linux. It allows you to run your small custom programs in kernel space and ask the kernel to program when on any kernel level user land function. And these programs can have access to kernel function arguments and returning values. So it's ideal for observability purposes. You can observe your system behavior just by signals from. And when we talk about eBPF doesn't solve itself. You need it, it just allows you to run your programs, and you need to implement these programs and understand what which information should be gathered and here you can use eBPF in many like many ways. The most common way eBPF are kprobes. When you run your program, every kernel function call, some process tries to establish TCP connection, you can your program can be called by the kernel, connection destination, process ID, who initiated this connection, and so on. But this can be tricky to use kprobes because the Linux code is unstable in terms of it can be changed anytime. When you use probes, you should understand how like kernel functions changed over time. So address it. Linux kernel also provide trace points. Trace points is a statically instrumented kernel, and there are some guarantees that these trace points will not be changed frequently, and it allows you to use more stable API. The next mechanism is called probes. Touch your program. For example, your link application calls some function, for example, HTTP request, and you can attach your program base function call. It also can be useful, but it's like we will talk about this a bit later. Maps the way for some between program calls in the kernel space. For example, I want to track establishing TCP connections. You can write some value map and kernel space, and then retrieve this value on the next connection steps, like when connection is actually established, and report data using values. And perf maps exchange data between kernel space and user space. For example, when you want to report something from the kernel level eBPF program, or for example, monitoring agent, you usually use perf maps. Next, we at Karoot we implemented our own, which is open source under Apache license. It's Prometheus. It gathers all telemetry signal metrics profiles. It uses eBPF to linears on nodes, track their communication, and so on. It can capture application level protocol such as HTTP, and most popular protocols are supported out of the box. It also gathers write telemetry data, network latency, containers. It tracks connection latency and a lot of. And now I want to explain how our agent, when it's possible, we try to use trace points instead of keystrokes to have more stable API. First case, we track our agent task tracks task new task trace point to being warned about new processes on the node. Then the agent received information from the kernel, like new task is created with process B. Then it can obtain all container level information about the process using the proc file system. And then we want to track process term, but if it's possible, and whether this has been terminated by the home killer or not. And for this purpose, we points. The first one is mark reactive, when we remember that process process ID 123 has been marked as a victim, and then when it's actually terminated, we retrieve this flag and report to that the process terminated by the home killer. If not, just track that process finished. Also, agent tracks file opening event to understand particular disk and volumes by the particular process or container in our case, and also for log discovery. Then agent uses connect syscall. It obtain process ID and the relevant file descriptor from the kernel, and then it can recognize the container which initiated, and by tracking TCP, changing TCP state of the TCP connection, destination address, and it produces pretty granular, and we can track destinations, TCP connections. And also we use retransmit trace point to be able to monitor TCP transmissions, but like usually monitoring engines report in Linux kernel report only the total numbers of events, but it cannot answer questions whether the connection experience network issues such as having granular metrics like this particular container had, for example, 1,000 TCP transmissions, and that can highlight, and we have this metrics per destinations and what's happening between two particular containers in our network. And also to track application level protocol, our agent tracks write to socket, send message to the socket, and so on, like all variations, possible variations, and same stuff for system calls for receiving information, and implemented ways application level protocol parsing for just performance. eBPF programs in complexity, that's why we cannot perform full full-featured application level protocol parsing right in the code. And we just use like small and super performant protocol parsing in kernel, and then application level payload user space to proceed like full-featured protocol parsing. And like this is an example how we can monitor communication between our applications. When you do some HTTP request to some endpoint, what's happening in kernel? First step, you should resolve host name and the kernel level we SeaGL send message, and we can see file descriptor of the server. Then we can understand this particular packet is DNS request. Then we can recognize that within this similar socket we received DNS response. It allows us to measure latency. DNS request by parsing DNS protocol, we can understand number of the result and its status. Then we see TCP connection to TCS, and we remember this file descriptor number 5. In this, then we can understand that this HTTP request was made to this destination, and then finally we will HTTP response. And the kernel level protocol detection is pretty simple because we understand that the HTTP protocol, HTTP version 1 protocol method, and we can understand that it looks like HTTP request. And to detect HTTP response, we also use pretty simple and performant kernel because, for example, roughly speaking, kernel EPF programs you cannot use loops, and are pretty limited in complexity, and code should be simple and performant. And the completely different situation where we deal with we can add the payload in a TCP connection already have encrypted, and to be able to capture encrypted protocols, we need new probes, all user level functions like OpenSSL write function or SSL. So we can obtain encrypted payload just capturing this before encryption and after decryption trick, and with this trick using eBPF you can instrument encrypted communications. This is like few steps because when you monitor only system calls, you cannot understand that is encrypted payload. You need to understand this before, and our agent guess or understand that this particular process uses OpenSSL, and we need to set up some new probes for it. And also we understand the version of the library and understand offsets able to set up our new probes. And a few words about eBPF performance guarantees. Linux kernel has pretty advanced validator. It validates every program before loading, and the verifier has pretty strict limitations, program complexity, and that's why you can be sure that kernel function call will not be interrupted for time. And think of it like guarantees that eBPF programs will not bring performance. We have some performance benchmark and can prove that it's true, that we run benchmark under pretty high load, didn't see any performance degradation caused by running eBPF region. And also, when your user kernel space program and the map, which are ring buffers, so if your kernel program is not able to process all the stream of signals or data, you just will miss data, and from my perspective, perfect trade-off, observability purpose. And what we can achieve with PF. Here is a screenshot and environment. We have a bunch of services that communicate with each other using different protocols: HTTP, gRPC, PostgreSQL, Cassandra, MySQL, and just by using PF, you can see the full picture by just installing the agent and installing Coroot UI. Doesn't require any code changes and implementations, and you will see application level latency, network latency, number of errors, and so on. And also, in this case, we had, in this case, since the agent tracks each particular, you can drill down to any application and see like container level communications. You can see that catalog communicates on primary PostgreSQL server, and we know exactly what's happening between containers: application latency, network latency, TCP latency, and number of retransmissions, and so on. Then we can monitor DNS, because we know exactly latency of DNS request made by each container. We know it resolved, we know the number of errors, and so on. It also works without any instrumentation. Also, our agent gathers not only creates eBPF-based traces, like not actually traces, some sort of individual spans, but you can, with this data, you can particular queries. For example, you have some latency anomaly, you can see the area and see the requests which were affected. But eBPF tracing has some limitations, because in case of using eBPF, we don't know some tracing ID, trace ID. That's because it should be originated somewhere, and that's why we cannot bring all request ones related to a particular request together. In case of using eBPF, we cannot propagate some sort of trace ID. There are some projects that try to change payload to propagate trace ID, but I don't approach because I believe observability do not change. They cannot change anything. And also eBPF can be filing. It's just once 100 milliseconds that dump stacks every application and data to explain CPU usage anomalies, such as you can select spike, the code level distribution of time allocated by each function is useful, and also you can select some anomaly with previous period and easily understand what changed. And here is a design diagram of root, its own node agents. It also can receive logs and traces generated by OpenTelemetry SDK, and it stores metrics in Prometheus and logs, traces, and profiles. It can be run anywhere, Linux, on kernel F, and it's like pretty simple, especially when you can install it just one command. So try root ability. It has advanced database monitoring support. Its agent also provides some database specific metrics, and this simplifies database monitoring. We have also we have two editions of the open source distributed under Apache 2.0 license, and enterprise version, which is like $1 per month per CPU core, but you will have sign-on, role-based access control, and automated root cause analysis. That's it. If you have any questions, I would love to answer.
He can't hear us, right?
I don't think so.
No, it's
Yeah,
muted.
maybe if you go through the microphone, but not sure.
So there's no way to communicate with him?
You have a question?
No, but I feel bad.
I think
they
he's
didn't hang.
unmuted.
Hmm?
I think they muted.
Oh yeah, he did mute the mic. This is awkward.
Yeah.
We got what we paid for.
Unmuted. But it's a little off.
I'm just gonna step away.
At the front.
There's a box to the side.
Oh, okay.
There you go.
Very conversational yesterday, but I was curious. So, do you feel like you have a lot of support in your context for
Questions?
Okay, cool.
So you can start when you're ready.
Okay. Thanks. Hi everyone, my name is Anjan. I'm a FOSS contributor, Postmarket OS contributor, and an SXML co-maintainer. I've been contributing to Postmarket OS since 2020, and this is like my favorite thing to work on. So I'm gonna mention like a lot of cool stuff. You can check out the stuff I mentioned. There's gonna be links on my website, momi.ca. So this is the beginning of Postmarket OS. Postmarket OS is a standard Linux distribution. It is based on Alpine Linux. The project originally started with wanting to install an environment that is very similar to what you would get on like Fedora, Ubuntu, etc., onto your Android phone. So it's a standard Linux distribution on phone form factor that has like a USB modem for calls, text, and like mobile data. You can install desktop GIMP, desktop Firefox, have a regular Unix-like file hierarchy, use rsync to copy files over SSH, and basically do anything on your phone that you would do on like a Linux desktop server, laptop, anything like that. So provided you use a Linux laptop or desktop, there's nothing really that you need to learn to make new apps. Anything you know from all these devices carries over to all your other devices. And yeah, there's similar projects to Postmarket OS for mobile phones like Mobian, which is Debian on phones, and Arch Linux ARM, which is Arch Linux on phones. Oh. So what's wrong with Android, right? When an Android manufacturer uses the Linux kernel, they fork the code or copy paste and patch for each new Android device and version. This heavily patched kernel is incompatible with the version released by the Linux Foundation. Android devices with forked kernels cannot be maintained by the community and community long term. And unlike your old PC, the Android device that you bought is dead as soon as the manufacturer decides to force you to buy a new phone, right? If you elect to continue using the forked kernel after support is dropped, you are vulnerable to security vulnerabilities like stage fright, which plagued over like 1 million Android devices. So Postmarket OS ships mainline Linux kernel support for old Android phones. And to achieve this, the Postmarket OS community mainliners look at the GPL vendor kernel source code and upstream the patches to the version released by the Linux Foundation. So you get security updates forever in contrast to usually like that we have seen. So today we have a flood of other insecure devices like smart TVs, watches, smartwatches, smart devices, and Postmarket OS can be used to improve user freedom on these devices too. So here are some of the user interfaces for phones. From left to right here, we have the Android UI on the left, Plasma Mobile on Postmarket OS, and Phosh on Postmarket OS. Phosh and Plasma Mobile are great user interfaces, but they try to emulate sort of the Android UI, which works for a lot of people. And I wanted to make something that was like more hackable, which is when I stumbled upon SXMO and helped improve it. So this is SXMO. For a window manager, we use a tiling window manager like DWM or Sway. Moreover, we have a B menu / D menu, which is our like fuzzy finder menu systems. You can use hardware buttons to interact with these menus, like volume up and down. Calls are managed by Modem Manager. Wi-Fi and mobile connectivity uses Network Manager. And with SXMO, if you add something to your cron tab every time your phone goes to sleep, My Next Cron utility will calculate when your device needs to wake up in order for your cron jobs to run. And listgd provides our comprehensive like gesture system, so you can find like any gesture to any command on a Linux system on your phone. Everything is plain text files, so text and call logs are plain text. You can grep them to your heart's content, and you can SSH into your phone and send text over whatever text editor you like, Vim or Emacs. We also have a hook system where user-defined scripts are ran on system events. So you can define custom behavior via shell scripts. So when a call is finished, started, or you get a text, you can define custom behavior to interact with all these events. So here are some user interfaces for weird form factor devices. So you can install Postmarket OS on wearables like watches. And for that, we support Asteroid OS, which is a free software UI for watches. Since we also support devices that have the form factor of a TV box, we support an entertainment center UI called Kodi. So yeah, you can also install like standard Linux desktop environments, right? So you can install Sway, XFCE, Plasma, GNOME Mobile, which is GNOME's shell from the desktop with a couple of mobile patches, or go minimal with like console only. In total, Postmarket OS supports 20 UIs, and the installer will let you choose any UI on any device you've installed Postmarket OS on. So not shown here is Frame Buffer Phone, a phone UI that lets you call from a TTY, so your phone only shows a TTY and like a keyboard. And since a device may not have like a working touchscreen because of like hardware or software is broken in some way, the variety of UIs lets you repurpose any device you own for any useful use case you may have. So the question is, how do I get a Linux distribution on my device, right? To get a Linux distribution on all these devices, we have developed a tool called PM Bootstrap. So we say Postmarket OS boots on over 500 devices. Boots means it boots up and loads a Linux kernel, but everything from the display to Wi-Fi is like doesn't work. To everything pretty much works except for like a camera, right, which is the OnePlus 6. So back to the install process. On these smart devices, TVs, phones, etc., each device requires its own special workflow. Moreover, this workflow changes depending on the host Linux operating system, right? So lots of manual steps and guides would quickly go out of date because they just need to be updated constantly. So we had a bunch of shell scripts originally, and all these shell scripts that Postmarket OS started with morphed into Python scripts, which were written in Python. So Postmarket OS is based on Alpine Linux, and Alpine Linux's mini rootfs is 9.1 megabytes. Because Alpine is so small, PM Bootstrap will build the images for your device in Alpine change roots. So you can use PM Bootstrap on most Linux distributions. PM Bootstrap will allow you to easily include any custom patches in your images, kernels or packages you may be developing. In addition, it's very easy to package for Alpine Linux, right? It's all shell scripts. It's very similar to Arch's make package. And Alpine has both stable and rolling release. Consequently, Postmarket OS's packaging is very easy. Bootstrap lets you choose between stable and rolling release. PM Bootstrap can also set up multiple different change roots for different experiments that a developer may be working on. Ccache and distcc setup is automated. The different flashers for all these devices is abstracted away. If you've ever rooted an Android phone, you know how annoying that is. All this makes it very easy for users and developers to reproduce the issues and successes that other users and developers have had on these 500 devices, right? Where people have tried and shared their results. PM Bootstrap is so useful when developing the Linux kernel that some developers consider it like a core part of their Linux kernel development workflow, even when they're not working on Postmarket OS directly. So the Postmarket OS community, the Postmarket OS wiki has a wealth of information on how devices work, Linux internals, how to even fix your Android phone. In fact, I got the inspiration for that like Wake on my next cron job utility while reading the wiki page on how RTC Wake works on Linux. The wiki also has a device matrix, which tells you what is supported on what device and what you should can get easily on eBay and all this stuff. Yeah, you can compare that with what you would get on eBay. So yeah, the testing team tests new releases and contributes greatly to getting stuff upstreamed. Ad hoc and hacky patches are not allowed in the main repo. PMOS is upstream first. Many packages have very little patches, and we work with upstream to improve the software we use for as many people as possible. Finally, the project develops a plethora of tools which are usable everywhere. Installing post-market OS and enabling full desktop with PM Bootstrap. And when you go to turn on your device, you will be greeted by Unlocker, which will unlock the full disk encryption. And this works on all touchscreen devices. So yeah, when your graphical user session is unresponsive on your desktop, you can easily Control Alt F2 and switch between TTYs and click kill applications. Running Linux on a touch device, you can use TTY escape, which will listen for you holding down volume down and power down 3 times. And TTY escape is shown to the right here. By doing this combo, you will be switched to another TTY, and you can type in commands using TTY escape's touchscreen keyboard to fix your phone, or and work on it remotely. So I've found the reliability of calls on both Android and post-market OS lacking. Even though on post-market OS, the reliability is slightly worse than Android, I can improve it on post-market OS. As such, I've been looking into using Chiogram, which lets you make phone calls over a regular telephone network and using your XMPP account. I've started developing a CLI daemon that will let you use the service to make calls on mobile Linux. If your cellular network is unreliable, your XMPP account will always have a record that you missed calls or whatever text you may have had. And Honeybee's stack is simpler, so it will work on more post-market OS phones. Honeybee is CLI first, and it has those hooks from SXMO. Here's Meepo. Meepo is an OpenStreetMap viewer designed for mobile Linux desktop generally. It's offline first, lets you download the map data to your phone. Overall, the tool is very fast, and it includes a JSON API with a pinning system that gives you point of interest info and turn-by-turn navigations. There's also mob route, which lets you view like transit data from your phone via the CLI and parse transit data. Also Transito, which is a GUI for mob route.
Out of curiosity, can you actually use that for doing like off-roading and stuff like that?
I'm not sure.
Okay.
Yeah, so post-market OS is extremely flexible, and phones are Swiss Army knives with a ton of features. Old phones can be used on a variety of situations, which are not just your daily driver, right? A daily driver Android/iOS replacement. Here we have someone running an entire web server. It's called compost.party, using an old phone and a solar panel. And it all works because the old phone uses post-market OS. Indeed, old phones can be used as Raspberry Pi replacements, robot touchscreens, monitors for your 3D printers. Yeah. So post-market OS now lets you even run Steam games on your ARM devices. So on the left, we have post-market OS deck/switch using OnePlus 6 running Half-Life. On the right, we have a Xiaomi Mi Pad 5 Pro running Tomb Raider. These games were not designed to be ran on ARM devices, but it all works for Box86, which are ARM to x86/64 emulators. You can check out Calc Programmer's YouTube channel for these devices in action. The performance on these devices is actually really good for like playing these games. Yeah, post-market OS is currently like great, has a lot of really good use cases, and can do a lot. But the goal is to completely replace Android and iOS and remove all of this attention economy from our lives. For this, people usually have to rely on like banking apps on their phone, messaging apps, and all of that stuff will probably not be available on Linux. So the Android emulation layer aims to be like Wine, but for Android apps. Here we have NewPipe running on Phosh via the Android emulation layer. NewByte reports that on their Mastodon that icons, but it works very well. General reliability of the entire system is a constant work in progress. There's an investigation ongoing about making immutability in the distro in a way that preserves the hackability of post-market OS generally. Connectivity and telephony is fairly good on these devices, of course, anywhere in the world. And yeah, we're working towards that. Currently, most devices do not have a working camera. There has been some stuff to get the camera working on the Poco F1 and the Pixel A3. Cameras are actually the most complicated part. And yeah, there's like progress being made here, which is like impressive. And in general, user space needs work. Travel apps for like everyone, right? The goal is to be usable for your grandma, to your hacker best friend, and everyone deserves a phone that's not a constant distraction. Cool. So why do I work on Postmarket OS? Well, first of all, I like seeing file release to release. When I'm out, I don't spend as much time on a phone. I just like enjoy life when I'm using my Postmarket OS phone. My phone is more of an assistant than a distraction. And when I've had to use an Android phone in the last 3 years, I found it like very distracting. I like supporting the long-term solution to the mobile duopoly. And finally, I like seeing the improvements that Linux Mobile has made to my GNU+Linux desktop. So for example, SXMO has helped with a daemon manager called SuperD. No maps like Dino work better under tiling window managers because they're mobile adaptive, and there's more testing for the general Linux ecosystem. So Pipewire Bluetooth bug reports that have come out from like us investigating stuff in SXMO. So I recently got a Lenovo X13S laptop, which has one of those new ARM processors with like a really good battery life, and installing a Linux distribution I trusted on this laptop was easy because of Postmarket OS. And ARM devices are usually a pain, but with PM Bootstrap, Postmarket OS, and the wiki around it, it lets me use all this weird hardware as a daily driver. Before I got into Postmarket OS, I had developed some Android apps, and the entire process gave me a headache because it was all in Java, and it had a ton of things that were only a problem on like. In contrast, on Postmarket OS, the cost to develop software is significantly less. Since it's all the same tools that you're familiar with on the desktop, you can write same languages you're familiar on the desktop. Yeah, and use any framework, any debugger, any tool chain on the desktop. And yeah, the OS I'm developing for has the same conventions I'm used to everywhere else. Any bug I fix or feature I add helps me on the phone, laptop, and desktop write a script for your desktop and have it work on your phone. I think that's like a great feature. And in short, I can SSH around and do everything in the way I know how to on any device I own. I now own, courtesy of Postmarket OS. Cool. So yeah, so you can join the SXMO community at sxmo.org. Clayton, who's here, and a Postmarket OS hacker, has started a really cool initiative to have FOSS Mobile committee that would coordinate between distros, UIs, and mobile hackers. One of the first actions this committee has taken is starting a FOSS Mobile matrix space where we have like listed all the chat rooms around Linux Mobile, other UIs, modem hacking, firmware hacking, kernel mainlining, and yeah, just other projects related to Linux Mobile. An easy way to help us is to join the Postmarket OS testing team and help catch regressions. You can reach out to me via my website, IRC, or the Fediverse if you have any questions and anything I said in this talk. Again, all of the links to the cool projects and like the demos, right? They're on my website, momi.ca. And yeah, we'll be tabling for the rest of today down there with the Postmarket OS green booth. So yeah, if you have any questions, you can talk to us in person. Cool. Thank you. Thank you for coming to my talk. I think we have like 2 minutes for questions. So. Okay, yeah, we can.
Space between talks, but yeah, you can go.
Yeah. Okay. Anyone got any questions? Or?
Yeah. First of all, thank you. A Linux phone is kind of a dream, so this becomes a usable thing. That's awesome. Is there like a flagship device? I know you mentioned there's like 100 different devices with varying levels of support. Is there one that kind of development gets targeted at, and then things get like, if we want to try it, this is the best phone to try it on?
Yeah. So the question was, is there like sort of a target device just for? There's a couple of phones that are really good, and they're sort of in the sweet spot where they're old enough that a lot of people had them, and then they're powerful enough that there's enough interest around it. So what the best way is to go on the wiki and look at the devices. That will be like the tried and true answer about what works. But the OnePlus 6 works very well. Poco F1. There's a couple of other ones, but yeah, there's no like, there's the good device will always be changing. So it's best to look at the wiki.
Thanks.
Yeah. Those are the ones I've tried, right? And there's 500, so yeah.
What's SXMO?
SXMO is a user interface for post-market OS, and it just lets you. Just go back here. Yeah, it's just it uses a tiling window manager. It's very lightweight, and yeah, it just does everything in plain text. You can SSH in, send texts. Yeah.
One more about that. How do you find using a tiling window manager on a device without a keyboard?
It's actually really good because the gestures, because Sway has the Sway IPC, we've bound gestures to all of the stuff you would normally use your keyboard for. So yeah, so it's actually pretty sweet. And yeah, I swear, but
V menu or something like that?
yeah, that's exactly the gesture. Yeah. Yeah, swipe to the left to go to the left workspace, swipe to the right to go to the right.
Super cool.
Yeah.
So I got a question. Are you mostly focusing on getting this OS to run as a phone, or are you more focusing on getting an old phone to run as a computer?
So the question was are you more focused on getting new phones to run or old phones to run?
Not quite.
Okay.
Are you focusing on like, this is a device that's sitting in a drawer, now it's going to become a useful computer or a web server like you described,
Mm-hmm.
or something that you will use as a daily driver phone? What's the focus of the project?
The focus is sort of like, yeah, it's like, I mean, we kind of want to do both. We kind of want to have like repurpose all these old devices. We kind of want like a replacement for iOS and Android, right? And yeah, it's not like there's necessarily like the one where it's just sitting in the drawer. All of the bugs you find on it will help fix stuff that you're gonna find on your Android iOS replacement device. So it kind of like all of this fixes kind of translate to both, and really, it's all about like what people want to work on. Like if you want to help port a device, garner more attention. And the better a device works, the more people will take one and buy one and then like improve it. Like I saw OnePlus 6 work really well in demos, and I was like, hey, I want to improve it on SXMO. And really, if that person hadn't done all that work to improve it, right? So it's not like either or. Kind of just whatever people want to work on, we help them with.
Gotcha. Thank you.
Cool. Okay, yeah. If any other questions come up, we'll be downstairs. Thanks for coming to my talk. Cool.
We're just gonna thank you for your talk.
Well, I have my Android phone, but it's my phone.
is 11:30, so let's start the talk. Yeah, take it away. Oops. There we go.
Yeah, ready?
Yep, you're on the air.
All right, thank you. Welcome everybody to this little techno-spiritual ritual for the liberation of computer souls. We're gonna talk a little bit about Ashway. So, as you all know, there is a system, and Linux is one of its kernels. Looking at the screen, hopefully you can see the thing I see. But the main question that anyone barely asks anytime is, what about the soul of the right? And the short answer is, normally it doesn't have one. Unless, of course, you own a framework. Everything is different. Why is that? That is because of coreboot. So the actual obviously lies in this little grader that you have inside your PC. That is the little guy that as little as 4 megabytes and 8 megabytes in some others, and a tandem of 8 plus 4 for a total of 12 megabytes is responsible for all the bad stuff that can happen without you even knowing your computer. So just to make it slightly longer, to really drive it in, as some of you might remember, there was a certain person who told us about how the NSA exactly is their technology, right? And obviously that happened 10 years ago, and there's no indication that it ever ceased, because why would it, right? So the soul of your computer, doomed in the fires of proprietary, still decided to backdoor your motherboard. And obviously it's not only Intel. We know that AMD does the same thing. We know that cell phone vendors do the same thing. And really there's little to no escape from that, right? So yeah, as it happens with all backdoors, when management engine is finally cracked open, every computer running on a recent have a huge security and privacy. And obviously, since it's a backdoor, when is that going to happen, right? Or whether it has happened already. So that's just something to bear in mind. And of course, in case you forgot, this dude who told us about it, apparently lately not many people remember him. Not many people even know who this guy is, judging by some conversations that I've had in recent, all sorts of people, right? Which is kind of soul crushing. But yeah, so we could just panic about it, right? But we could also not panic, and this is what we strongly suggest. Because instead of panicking, we could just install coreboot. So coreboot is a free software BIOS system, which actually is a BIOS system. As you recall, BIOS just stands for Basic Input-Output System, right? So why is it that a BIOS can also communicate to some central servers, and for supposedly your own security, gives the capability to this central server of, for example, wiping your hard drive remotely, right? So it's obviously only for your security. You phone in to Intel and tell them the serial number of your computer, and they promise that they will wipe it out. So if you can do that, or if Intel can do that when you actually, that also means that they can do it whenever they want, right? So we like to think in terms of strategic paranoia. It's not about being paranoid all the time, but it definitely is about keeping some sense of what potentially can happen at all times. Some of the things that coreboot allows you to do. So first of all, you can have actual full disk encryption. You can even store your keys in your BIOS chip. Nice. obviously you get rid of the backdoors and the out-of-band remote management by shady third parties, or a loop-letter agency or whoever else. No more pesky whitelists or Wi-Fi cards and the like. So, in case some of you have changed or have had a ThinkPad, for example, and have tried to change your Wi-Fi card for a different one, Intel and well, now Lenovo really don't like that. So they just block your computer from starting completely, right? So Coreboot removed that completely as well. Now, something to mention about Coreboot that for me it's just proof of the evil of the system, right? Of the original BIOS that it has, that the computers have, is that you could just remove the original BIOS completely and install purely free software on it, right? And you could have all your hardware being found by the computer, successfully passed on to the operating system, and everything technically works, but then the computer reboots every 30 minutes and there's not much you can do about it, right? Coreboot, or the team behind Coreboot, excruciatingly painful process has actually managed to identify what part of the binary blob of the original firmware is responsible for the computer rebooting. Now, they don't know exactly why it happens, right? Or how exactly to stop it from happening through free software, free code, but they have managed to just leave enough Coreboot for that not to happen and everything else to work. To me personally, it feels like absolute they've done so. Now, last but not least, in terms of what Coreboot is good for, you obviously can have custom splash screens, which is important, and can go straight to Tetris from your BIOS, right? Which to me, that seems like a huge win. You don't want to really turn on your computer, but you do want to play Tetris. You can just put an operating system straight to the game, which is now usually in the before times, this used to be the only way to actually flash the BIOS. You need to have one of these little clamps, and you can obviously get a different clamp. They're black clamps. But in my experience, after flashing a bunch of computers, I really recommend you to buy the blue. It's gonna be like 4 times more expensive, but it's gonna justify its cost by the fact that you can actually reuse it more than twice. You know? The black clamp usually stops working very quickly, and let me tell you, I have some experience with that. A friend of mine and I, before we bought the original monoclip, we only had the black one, and there was a point when we were trying to flash a laptop, and it would just slip out from the chip, right? So we even tried actually holding the clamp on top of the manually, while the other guy was like very quickly trying to input the right commands. Obviously, don't try that at home. You can do some serious damage. We didn't do some serious damage, but we were very successful with that flashing method, right? So eventually we got the blue clamp and it kind of worked out much better. The other way, and this is a couple pictures that we took of a friend's computer. He has a T420. So the issue that he had is that he was very enthusiastic about it, and so he one of the things you can do when you flash Coreboot is that you can unlock the BIOS for internal flashing. What that means is that once you have installed through hardware first time, you can actually just updates skip from your terminal in Linux, right? So my friend was messing around with his firmware, trying to add a different splash screen,
or there's a known bug where under certain circumstances, when you boot up a booted computer, part of the screen like white or just black, and the image that you put in the as a boot splash gets compressed into of the screen, right? So my friend was trying to fix that down from me, like an hour drive or so, maybe a little less. I remember it very clearly. The first day that we flashed his computer, he went home, immediately started messing with it, and like half an hour after arriving home, calls me and says like, "Hey, can I drive back to your place and lamp again because I just bricked my computer," right? So after 3 or 4 times like that, just after arriving, he decided that he has had enough of it. So he found that on the motherboard of the T420, there are actually some where you can solder cables that connect to the flash chip. So he soldered these cables, and then he didn't have a DVD reader in the DVD bay. Just put these little connectors in his DVD bay so that he could hook up a Raspberry Pi from the outside with jumper cables and flash without having the clamp available. And after that, I'm not sure how many more times he bricked his laptop, since he didn't have to tell me about it. I was the one with the clamp and he didn't have one, but he didn't need one anymore. We'll never know. We'll never confess. So now that there is another way to do it. It's much easier. Well, yeah, that's hackerman. If you want to be one, you can be one. Buy a T420, and right. So there are other options now. Specifically, there's a thing called Ivy Rain, one instead of the first I, that actually allows you to unlock the flashing of the BIOS chip from software directly, which is amazing. It doesn't work for all computers that are compatible with coreboot, but it does work for, so there's one more laptop that is which is the T440P, which is also compatible with, but it's a little bigger and chunkier, and the one generation of the processor really doesn't make that much of a difference in terms of the power of the laptop. So the recommendation is still to get an X230, because it's still the sexiest machine you can get for coreboot. Don't mind me, I have one, so that's maybe I'm a little bit biased. Ivy Rain is very comfortable to use. Most of the computers listed there are less than $200 when you buy them off eBay or anywhere else you can find them, and a lot of them are also less than $100. I've found some amazing deals. Like once I found a P400, which is a little bit older. Let's say it's just a classic. So I found it for about $40. A working battery, a charger, and everything else. I've bought, which if you're familiar with Richard Stallman's tech stack, he used to own an X T60 is like the cousin of that model. You can find one for $50 to $60 as well. So it's very recommendable. And most importantly, of course, all of these are onto you. They're amazing computers, and you can drop them, as I personally have, various heights, but not for any damage. So, yeah, I think I was a little nervous and rushed a little bit through this, but now getting to the actual part of this talk, please join me in prayer. The name of the kernel, clamp, and the log files. Blessed be thy network interface, thy computer, and the files. May your fingers dance on your keyboard with the ease lives in the wind, and your screens never flicker with voltage. May your code compile without debugging and your test runs end before your workdays do. Ramen. And now, since you've been blessed, you all get 10 XP. Blesses your system. In case you're interested, this is the QR code hackspace. We're called Kernel Panic Room. Since I have a little bit of time, I'll explain why is it called like that. Well, kernel panics, most of you probably know, are a very solitary experience, right? There's really not much you can do in terms of asking for help, because likely the kernel panic you are experiencing is your own fault. You did something that nobody else has or in a way that nobody else has done before, and so there's nobody who can really help you. So the kernel panic room is a place of worship where you can go with your computer and suffer your solitary kernel panic, accompanied by others who are also suffering kernel panics, which makes it quite bearable. And if you're interested, and if you're at some point in Mexico, Querétaro, like 200 kilometers north of Mexico City, you can just open your trusty OpenStreetMap and look for the Temple of Entropy and our Lord Sani, and you will actually find our address. We're officially on the map as a place of whenever you're here, we'll be happy to worship with you. Thank you. If there are any questions or anything, I'll be happy to answer. Not sure what questions could you ask of me, but I'm here.
I've got a question.
Okay.
Is there anything about making an end run around the TPM?
Anything about what? Sorry, about what the TPM?
Trust Platform module.
Yeah.
Like, is it possible to use core boot to imitate the existence of a TPM without having, as mentioned before, a backdoor into your entire computer?
As far as I know, you can use the TPM with core boots, but that is something that's better asked of manuals core boot. Yeah, so I have working knowledge of, but I am not a developer and I'm not a collaborator with the project. So yeah, that's something we can investigate outside of this space, and I'll offer all the help I can give.
All right, thank you.
Yeah.
Looks like that's it.
All right. Well then, have a nice extra coffee break on my behalf.
Thank you very much.
Thank you. Thank you.
Thank you. See ya.
Thank you. See you soon.
I don't think there's right.
Okay. Yes. Give me a spotlight. Okay, thank you. What's your name? Thanks, Cameron. Everybody, thanks, Cameron. Cameron's volunteer. I'm not going to start yet, but I'll tell you about these books. So I took a year to write this book. I didn't have a publisher, and it went really well, but I don't think many people know about it. So the biggest issue is spreading the word. I had an awesome editor and then an awesome volunteer editor, and then my partner edited. And I think my son might have checked it out. Oh. Do you want to read it?
Sure, if I have time.
I'll take one. That sounds great.
Okay, cool. Here's how to pay me. selfhostbook.com/buy. I'm offline, which is kind of like I'm seeing if I can do this whole thing offline. Talk about hosting servers, but I'm going to do the entire thing offline. Okay, anybody else want to buy one?
I'll buy one.
Say that again.
Build is available for it too, right? You can build it.
Build, yes. Yep. It's open source. It's gratis and libre. And I also today I'm raising money for SeaGL. Yes.
I bought one a few days ago online, but I'll buy another one just for SeaGL.
Oh, you're awesome. Yeah.
Do you want me to come up with campus or something?
There's yeah, so I can accept those. Yeah, that's fine. I can accept almost any method. My preferred method is PeerCoin because I'm kind of checking it out, but I actually don't know what the value of that is in dollars, so maybe I shouldn't do that. That clock on the wall looks slow. I'll start when my watch says 11. 3 minutes. Anybody online? Can you wave? No, you can't, can you? Or you can, but I won't see it. I wish you could see who is online. Wouldn't that be rad? Is anybody watching a chat room related to this? Not asking you to. I'd prefer focus and like we're all attentive or whatever. But sometimes people go in the chat and expect that I'm going to answer questions there, and I just want to make it clear. I love you folks. I'm not going to watch the chat. Okay. I can't. My brain can't do it. Classic Seattle day today. Who's in from out of town and wants to share? Yeah? Cool. Anybody first time SeaGL? Whoa. Let's see, what year did we start? It's 12 years ago, right? You count this year when you're counting. So that would be 2012? 2013, right? No. 1, 2, 12. Help me out. 2011? Why is that so hard?
2012.
2012 sounds right.
Yeah.
12, 13. 2, 2, 3. But you count 2012. You count 24. I think that's right. Yeah.
It's done.
It's time. Thank you. Hey, welcome. Welcome. Thank you so much, SeaGL. And by SeaGL, I mean the people who run it now, who are awesome. Any volunteers in the room right now? Thank you. Thank you so much for volunteering for SeaGL. It doesn't happen. And the fact that it's still happening and doing well is really lovely. Am I supposed to wear a mask?
No.
Is the speaker? I don't. Okay. Let's see. Any other housekeeping? And feel free to remind me. I'm going to try and make this as possible. So be ready for that. I mean, it won't be like pop quiz. It'll hopefully be fun, but okay. And it looks like the audio is going through. I don't think people online are necessarily going to hear y'all. So if you raise a question, allow me to repeat it. That's the copyright and license for this talk itself. You know, I don't have a post up that shares this content, but if you hit me up for it, hey, I want, you know, whatever you want. Talk, source code, book, of course. You know, I got a stack of them here, but just let me know. It's all for you. But that means you got to like figure out how to contact me and then do all that. And all that info is at selfhostbook.com/contact, I think has that. So again, I'm going to try this offline. So we'll see how it goes. A few updates here, and let me go bigger. Oh. Okay, so there's also an ebook version. If you can, buy it through Gumroad or Lulu. They're smaller distributors. So I've been doing a book tour that's been going well. It's just what I've organized myself. It's mostly online, but I've gone to conferences, run workshops like this. There's a couple videos online, and I've been collaborating with this guy named Ethan Shawley out of New Jersey, who's awesome. So if you're trying to keep track of the latest, boy, I would recommend and figure out a way to keep track of the best. But if you want to keep track of the latest, does that distinction make sense? Like try and find the best and then stick with it and don't change often. And this is because kind of going along with the ethos of the book, the point of the book is to serve the people you're doing it for. So it's about small group hosting, community hosting, not, it's called self-hosting because that's like, but not just for yourself. That's kind of a big point I try to make in the book. So it's been really good collaborating with this guy, and I think Ethan does a good job of finding stuff that's worth your time. I also have a thing in the book. Let me jump to the end here really quick. 711 is like a nice little handy little checklist for you. Oh, what should I look for? And so this is, and again, I'll share all this in the presentation and everything, but this is news. So self-host with a dot for the O. That's run by Ethan. And then this is my thing. And I set up a chat room. There's only 12 people on it so far, but maybe it'll grow over time. I'm really a stickler about like people agreeing to rules up front. And I want to make sure it's a nice, great place for people. Like I want to promote safety and like it should be productive. A lot of these giant channels you'll hop into are a little scary to me. So maybe not to other folks, but this is a great place to find stuff. And then does anybody else have any ways they find great stuff to like that's worth their time to run? Where do you look, or how do you decide whether to spend time trying to set something up? Anybody? Okay, no, we'll come back to it. No worries. So that's, whoops. Okay, so there's the updates. Any other questions here? Yeah, go ahead.
The reason why I set up a service is because it serves a purpose. It serves a community. There's some functional reason to do so.
Okay, nice comment from the. I like that. The reason I set up somebody shared. The reason I set up the service is because it has a function. It serves a community. Okay. Oh, it's in the Seattle Public Library too. Oh, love you guys. So here's some services I wanted to talk about today, and I'm going to be a little bit demo heavy and integration heavy because I think that's one of the key benefits. Like you have one server, you got a LAN. It's great to leverage local data. So you got a thing running right next to it, and they can both get at the same data. Great opportunity to collab those two things together to integrate them. So these are just some of the things I've tried lately. I don't think any of these are in the book. Pi-hole is, but I just mentioned it. I don't even, if you download the software that comes to the book, it doesn't help you set up. But I have, a little snippet of config you can use to set up your own Pi-hole. There's lots of ways to run Pi-hole, and I think some people might recommend just getting its own box or a VM. Maybe that's easier. I'm very comfortable with Docker, and so I'm doing a lot with containers, and so I'd recommend, finding something that works for you. But that's what's been working for me. Any of these in particular that somebody's interested in and wants me to? Yeah.
Actual budget.
Cool. Okay, I'm also writing a blog post about that, and it's like a 101 how-to, because actual budget, self-hosted, free and open source, budgeting, financial management platform, focuses on the budget part, but you don't actually even have to use the budget part. The only critical part is transactions. So you get transactions from your bank, you categorize them, and then you can do whatever else you want to do with it. But at the very least, it's a great way to gather all of your transactions, which I think is like step 0 to being able to manage your own finances. I love it. Me and my partner have been using it now for, I don't know how many months, but we used GNU Cache. We tried to use Mint. I don't know. We used some proprietary ones, and none of them. I feel like they're punishing you. I don't know what it is, but they just this one, it's fast. I'm already past the pain of categorizing, and it has a great rules engine. So this one, definitely worth your time. It checks all my boxes for is it worth it? And is it, does it have good people behind it and good momentum? That's the word I'm looking for. So I think it's got all those. And I don't think I have a demo of that set up, but I think I could flip on the demo real quick. Maybe, we'll see. The other one I just started playing with is Home Assistant. Anybody else using this? Yeah? Okay, anybody also heard of OpenHab or Gladys?
Yeah, I think OpenHab was a little bit earlier than Home Assistant.
That sounds right.
I feel Home Assistant kind of surpassed from a community standpoint, but I could be wrong. I've never used OpenHab, but it was when I was exploring years and years ago.
Yeah.
Home Assistant was very, very new.
Okay, cool. Comment was that OpenHab looks older, and honestly, I looked at it today and it looked dead. I mean, there wasn't very much activity.
Home Assistant has such great traction.
Yeah.
And it's a great community. I'd recommend, if you haven't used it or checked it out, I'd recommend checking it out because it changed my life. And I even know now I don't do pretty much anything in it. Okay,
here, pause for a second. So Home Assistant, change your life. Awesome. And recommend checking it out. It's got great momentum.
Yeah, it's so stable. It's hilarious.
I was struck by the speed. I flipped that thing on, and it's instant feedback. They did such a great job of making the UI just instantly. What do they call that when it's it's syncing in the background and you don't even notice? It's incredible. So I just started playing it with the other day, and did anybody see my chicken door talk from years ago? Okay. Oh, cool. Well, go check it out. So if you search Raspberry Pi, chicken door talk, Adam Monson, something like that. So I did this years and years ago. My partner and I set up a door that opens with the sun and closes with the dusk. Opens with the dawn, closes with the dusk, so the chicken can get out and be fine during the day, and then is safe at night. And it turned out to be a lot of fun. It was we used a Raspberry Pi. You could use anything, but everything I built to track and manage the sun, the position of the door, actuating things you're going to have at home, like doors, you know, garage doors, other kinds of doors. Home Assistant does all of that. So that could, I mean, I'm like considering rewriting the entire thing to just use Home Assistant as a backend, and then I would get rid of 90% of my code. When I switched to Nextcloud, I got rid of 30% of my code because it was a lot easier to post videos and chat and status updates to Nextcloud Talk. I don't love Nextcloud Talk, but anyway, I love the idea of gradually reducing it to 0. I have nothing to maintain, and then the chicken's safe and great, you know, that's a win. But Home Assistant, yeah, that one really blew me away too. So back to actual budget really quick, since we're talking about these. Actual budget uses this technique where almost everything is done client side. I think all of the data are in local storage in the browser, and so you have all of your transactions, which press down to like a meg maybe, which is no problem for a modern web browser. And then in the background, you have an actual budget server of your own. All it does is serialize it to SQLite. So on the server side, you just have your data saved, and you know, obviously backed up, all that. But client side is where everything happens, and it's brilliant. You can have 2 people. I almost figured this out accidentally. I'm like, oh, what do we share a login? Do we have different logins and access and share? You don't have to do any of that. You just open 2 browsers and they both sync. That's it. And I don't know how many, I don't think that scales, but for me and my partner, we're both using it at the same time. And the reason all that works is that under the hood, they're using conflict-free replicated data types, which is, anybody familiar with this stuff? CRDTs? So cool. Not new, but the concept is brilliant. It's that it uses data structures that are less likely to conflict. In fact, they almost never do, so that you enter a transaction, it's sent across the wire and saved locally. It's backed up. And then 2 people doing that, unless they edit the exact same. And even then, it's kind of like obvious. You're like, oh, I put in $12, I put in $15. So unless you're like, you can't have 10 people or maybe even 3 people. You know, my partner's entering a checking account, I'm entering a savings account, fine. So anyway, that like blew me away. There's nothing to mess around with. I already have security set up, so stuff is segregated and safe. And anyway, actual budget. Questions? Nope. Okay. Worth checking out. So let me.
All of 10.
Oh, all of 10. Let me just show you that. Set up a cool demo of that thing. So this one, the thing that made me want to try this one is it's designed to make it easier to share. So I'm always on the command line, and you get access to everything, right? Yourself in the foot 100 different ways. But you want to share that with your users so they have the same power without having to learn the shell, without having to accidentally, you know, they don't want to you don't want anybody to trip on the sharp edges. So you're like, oh, here's the thing you care about. Here's a big button to just do it. So that's what struck me about this thing. And I will, let's see. I think we have time to dig into the back end of this if we want to, but let me first make sure that's big enough. I think that'll work. Okay, let me do a mobile view actually. Okay, so imagine you're at home, you pull it up on your phone, and your kid wants to play Mind Test. They changed the name of it recently maybe, but Mind Test is awesome. It's a multiplayer 3D game, and all they have to do is click a button to get it running, and then, let's see, and then their world's online, and then their normal clients will work, desktop, mobile, whatever it is. So all this is a front end. Olive Tin is a front end to running scripts on a server. That's it. Safely, I would argue, because you can, well, I don't know. They thought enough about safety. I felt safe about it. We can get into details. How about that? We'll go with that. Anyway, yeah, so so far I've only used this to do, hey, AJ, done a couple little tests, and it's working awesome. Really behind the scenes are the Docker infrastructure I set up on my server, which follow the method in the book, obviously, and then this is a great way to just expose it to your users. Olive Tin. Yeah, questions? Yeah, in the back.
Can you spell that?
Yeah, Olivein. So that one's cool. I look forward to doing more with it. I get this feeling, certain ones like Home Assistant felt similar to me to Olive Tin in that it's made well, but it's made for someone who does want to customize, hack, integrate on their own a bit. So start the thing up, it's fast, maybe it's like efficient Python or 1Go binary, whatever it is, fast, and it's like, yes, hack it any way you want. The maintainers make sure that you have a solid, safe infrastructure to hack. Is that clear? So Home Assistant, I looked at it a while ago, and I remember thinking like, so it was way more on the hack side and too hacky. I mean, it was like very hard. You had to do massive configuration to get anything done. Well, now you can do almost everything from the web interface, I believe. So Home Assistant.
Yeah, back in the day, you had to do YAML edits, and it was really hard to diagnose. And now I don't know. I haven't touched the UI. I haven't even SSH'd in that box in forever. I just click
yeah.
Turn on when this happens or whatever.
Yeah.
They're dead simple now.
So comment confirming what I was finding, that now it's quite a bit simpler to configure and tweak. And yeah, I think I pulled it up on my phone and I could edit the dashboards on my phone even. It looks like it's same web UI, just scaled down to a mobile browser. So yeah, highly recommend those ones. Olive Tin looks cool. And so here I've integrated Olive Tin Docker. Olive Tin off the shelf comes with a Docker binary, but so that was kind of the thing. So Olive Tin is Go code and like a Go server backend and a web front end. Those are the two sides of Olive Tin, and you get one thing. You run it, it just works. But to tweak it, I think it's important to get under the hood a little bit. So I just sorry, I can't change directories and talk at the same time. So I wanted to see like, what if I need one more binary in, since I'm using containers, my Olive Tin binary doesn't have access to everything on the system. So I'm like, okay, well, I also want Docker Compose in there. So this button right here that says Start Mine Test is just running Docker Compose, but it didn't have Docker Compose. So I had to make my own Olive Tin image. So making my own image. Anybody done this? Made your own Docker image? A little high so I can see. Okay, so about half the room. Great. It was instructive to me to like get under the hood a little bit and try and build one. And the entire Docker file, just this chunk here. So I couldn't find any build instructions. pulled up the make file, and it was, I don't know. I was like, okay, maybe this will work, and it seems to work. This one's running right here. I kind of followed the steps that seemed obvious, and it's just like, I don't know, this just kind of blows my mind. Having to get all of my dev environment set up, this is all you got to do. You're like, give me the thing that builds Go code. So if we just look at lines 7 through 15 here, are getting the thing that builds Go code. installing a prereq, so Python shows up, npm can build the web UI, going into a place, user source app, copying in the source code into that container, and then build and run the build. So that all works. That builds the code. You end up with one binary. I didn't even adjust the platform, so I assume it's running ARM. Yeah, go ahead.
I was wondering, what is the Python 3?
What is
that's after apt-get?
Good question. What is Python 3? That makes bin Python or user bin Python run Python 3 for like a modern Debian system. Because now I think they've migrated from Python 2 to 3 at some point by default, and so it's handy when it shows up as just simply Python. So that's the builder. Who's done multi-stage builds in Docker? Yeah, okay, this is super handy. So like all the messy building stuff is done, and then you just toss that image, and then you start making a whole new image, and then you just grab a few things that were built. It's pretty sweet. So then, and if you do this with like, I mean, I think you can make containers that have like from scratch that have literally only that binary you build. So if you care about extremely slim images, that's a way to do it. So there's quite a few. This is the container, the image I use to run the real thing here, and it needs. These are just dependencies it has. I added Docker Compose. The other stuff I found in the upstream image. I don't remember what system they use as the base. It's probably Debian or something, but I'm familiar with Ubuntu 22.04. I happen to know I already had that image downloaded. So when I put that from Ubuntu 22.04, it's instant, right? I'm just using it from cache. So that's a sweet way for Docker development to like save quite a bit of time locally. And then I just wanted to make sure there's a user. Well, this line didn't really matter. I think I just grabbed a bunch of other stuff that I saw on the upstream just to make sure I'm like, okay, let's make it as close as I want. But this is at the end of the day, this is my own custom image, my own Docker file, basically following their pattern, but it's effectively a fork. But there isn't much to maintain, and I doubt they're going to change a whole lot of this backend, this bottom level infrastructure for how to run Olive Tin. It's quite simple. It's one Go binary. So this is a great pattern, though. You know, if I end up wanting to run whois or something that doesn't happen to be a trace route, I guess, I don't know. And you just add a line and then rebuild. So any questions about Olive Tin hacking?
Why did you have to do this?
So I built my own Olive Tin to get Docker Compose in there, and there are other ways to do it. Of course, on image startup, I could install Docker Compose there, but I wanted Docker Compose in my Olive Tin container so I could
run mine. Okay.
Yes.
You're running Docker and Docker.
Yes, but woo, yeah, it's not as crazy as it sounds, honestly, because really there's just because I'm mounting the host's Docker socket.
Yeah.
So it's talking to the same thing. The handy thing is just being able to use standard Docker commands from within there, from within the container. More questions? Okay. So go ahead and walk through the rest of this example here. And this config directory, so here I am on my host, and I'm just running things locally. I don't have a reverse proxy set up. I'm hitting things directly, localhost, just step of indirection I don't need at this point. For sure, I recommend on your own systems, have a reverse proxy going, and that's covered in the book. HTTPS certificates, kind of like you got to have HTTPS, and it's not that hard. But what I did here was I said, mount this config directory at /config inside the container. And I have a little script here that checks to see if the mine test containers are running. There's just one container in this stubbed out demo example, but it's quite flexible. This Python code will just write a little JSON file, and whatever's in that JSON file is appearing right here, online world 01. So Olive 10's great about grabbing data from a few different kinds of sources, YAML, JSON, something else I forgot. And you can use that for these little display boxes like right here. This is called a dashboard. It's my games dashboard, and the first section is a mind test section. So I'll probably want to add what's another self-hosted FOSS online game server? What's the one with like, it looks like you have like a massive map and like you have armies and they go all around. Asgoth. Wesnoth, that's the one. Anybody running that? Wesnoth? Yeah, nice. 1, 2. Anyway, I played it, but anyway, so the next section in this dashboard will obviously be Wesnoth, and that's the idea. Like, my kids could start and stop those quite easily. So this writes the state of whatever we want. I mean, this is totally arbitrary. It could hit the internet, and then it spits out a little. Let's do. So it spits out that little JSON file. Hey, and by the way, in case I didn't make this obvious, anytime, just tell me to slow down, ask me to slow down, and then if you want any. Yeah.
I did have a question.
Please.
So Docker containers usually are relatively encapsulated. They don't get to talk to anything besides what's inside their container. Your Olive 10 seems to be interacting with other Docker containers, so is it still compartmentalized, or does it have access to basically the root of your device?
Yeah, no, that's a good point. I think this one effectively has access to everything because the container is running as root. It connects to the Docker socket. It could start anything on the host, I believe. So I only did this because I looked at the Olive 10 code. This looks relatively straightforward. I'm not going to have it auto update, but yeah, this is a privileged process, and there are better ways to do it. I wasn't sure how to get control of Docker containers on the host without opening it up that far, but
yeah,
maybe something like Portainer or the other ones that control containers are safer ways to do it.
Would you be comfortable having one of these, say, publicly facing to not just on your local internet?
Negative.
That makes sense.
The back?
I think what you did, right, is you used a volume mount.
Yes.
And that's how you made something on your local system accessible within the container.
Yes.
You said location A, and then within the container is also location A.
Yeah, so the comment was use a volume mount to make something available inside the container. True, but the thing I made available inside the container is the Docker socket, which lets you start and stop containers arbitrarily. Anything that's open in the Docker API is fairly extensive, so anything you can do with Docker, I've allowed happen from inside the container, whatever code is in there. There's a lot. I mean, I love getting down to the security analysis. I'm not good at it, so I'd appreciate help. But the way I understand it is the attack surface is. I'm basically just adding Olive 10 itself, and it's a little safer than if I had just run it right on the host. But here I'm kind of letting it go, do whatever it wants. So, sorry, I'm curious, were you wondering, like, is this secure, or just understanding what?
Do you personally think it's secure, was my question.
Yeah, no, I do feel safe doing this on my home LAN. Using code that I got a version of Olive 10 from a month ago. I took a look at it. I'm like, okay, there isn't much code. First of all, it's just running shell scripts. Looks like it's reasonable. There is a checklist in my book actually for these, but yeah, I'm trying to go through it in my head. And the way that the things that made me feel safe about it were those things. Okay, it's free software, many eyes, that kind of thing, and it's limited. And oh, I know another way. If you did want to go down the rabbit hole of making it more secure, you can arbitrarily constrain what goes through that Docker socket. There's a thing called the proxy. Oh, come on. Anyone? That's like a, anyway, basically you can intercept. So here, let me pull up that. Yeah, so var run docker sock is just like basically an open port, a socket in this case, to do anything against the Docker API. So what you can do is say, oh, no, things have to go through this proxy to get to the Docker API, and that proxy can limit what can happen and even what can do it. So you could say, oh, you have to have auth, like you have to have a key or something, or you can only do this 10 times. You can rate limit. You can do quite a, forgetting what the name of that proxy is, but I'm sure if you search like Docker lockdown security proxy kind of thing. I mean, not those exact words, but yeah. Anything else? Yeah.
You tried KVM. What do you think about KVM compared to Docker here?
KVM?
Yeah, kernel virtual machines.
I think that's a different domain, I would say. Docker would be more for, you know, isolating processes with respect to system resources while sharing the kernel. KVM, I think, isn't that used for like managing virtual consoles between machines, I believe? No, I'm sorry. That's a virtual machine manager, right? Okay, yeah. So a way to run virtual machines. So I think the question in general is like Docker versus, or containers, let's say, containerization versus virtual machines.
Yeah.
That's in the book too.
Okay.
If you want, I mean, it's argued to death in public, but I don't think it's a question of either or. I think you got to fit it to the right use case and what you're comfortable with too. So, but you can, I mean, today you can automate both of them pretty much the same way, like build and manage virtual machines as much as there are tools to build and manage containers, and no problem. I mean, yeah, the concept is solid though, right? Like, oh, how do we, you know, it helps to go back down to fundamentals and first principles. Are our services stepping over each other's toes? Are their dependencies all mungled up, or are we keeping them maintainable? Are the builds, or the way they're built, basically reproducible? Can they be upgraded? Are they isolated? Are they segregated? Like, there's all these kind of fundamental concepts, and I try and hit as many as I can in the book. But these are something you'd approach through, I think, just like standard computer science curriculum would walk you through a security class or something, or, you know, in architecture. You know, it's interesting. I was really lucky. I got to see about Linux. And the first thing he did was say Linux is stupid. And I'm like, how is Linux stupid? That's so statement to say. But it was, his complaint was that Linux starts a process, and what happens, so say you're tailing a log file. So you open a file handle, and if Linux changes, somebody changes the permissions of that log file while you have an open file handle to it, it doesn't matter. You already got that open file handle. So he had, I mean, getting down to the fundamentals of why it matters and where security matters and when, maybe that use case doesn't matter for most people in most situations, but it matters somewhere. For sure. I mean, so what is really helpful here, I think, is getting down to the fundamentals, like, okay, not just using Docker containers, but bundled dependencies and isolating things. It's a very important concept in all systems administration. Yeah, so the book is basically about, self-hosting is just kind of a lightweight approach to systems administration, I think. That's how but in my book is particularly about, okay, do that for people you care about, people you love, and share what you're doing, that kind of thing. Okay, got another demo? More demos? No, don't. Thumbs up. Okay. Not gonna do it unless you want it. Let's see. My demo is about. Did all of 10? Oh yeah, MeTube. This is cool. This is another offline demo with streaming video this time. So here's my website running locally. Here's MeTube. Anybody seen MeTube? Anybody using it? There's a million of those. Yeah, I know you have. Okay, so MeTube is a video downloader that any site that has a video on a web page, video from it. And it's really handy for, you don't need a special client, you can have it running locally. So I have it on my server that's like hardlined into the fiber at home, so it can download quite fast. And then what I wanted to do was have it show up. I have Jellyfin running locally as well. So Jellyfin is a self-hosted streaming media server. It's in the book, tells you how to set it up. But basically you have it at home and you have your own videos on it and you can stream them to anything in the home. You can share Jellyfin outside the home, but let's just assume that right now everything's in your local area network. So I got Jellyfin running, and then I add MeTube. Just kind of like follow through this thought exercise, if you would. And all you do is like plop in a URL to a web page with a video. And of course, you could automate this a little bit. Maybe you have a tiny bookmarklet or some other ways to like get that URL in there. But then all you do is hit add, and when a demo works, I'm always surprised. So it got that video, and let me just do it again. That was so rad. I'm just gonna see if I can downloads. And where did I put it? Adam. Sorry. Again, I can't change directories while talking. Check SeaGL 2024. Okay. So here's MeTube, a download folder, and then I plop in the web page with the video URL, and then should download it and show up here. And then I'm not going to play this thing, but okay, there's the video. It works. So pretty sweet. And you can point at kind of any site that hosts videos.
Nice.
Media Goblin. What are the free ones I know of? What's the, yeah.
I just had a question.
Yeah.
Sorry. So this is the front end for YouTube DL.
YouTube DLP, yes.
Okay. And
Whites, yeah.
I was just curious, have you compared it to like YouTube Material and Invidious?
Oh, yeah. So Invidious is a different way to get at those videos, right? That is a proxy kind of deal. What was the other one you mentioned? YouTube Material? I haven't seen that one. But I did notice that there are about 100 things in this space. Oh, I mean, not too surprising, right? Like people don't want what YouTube's selling. Like recommendations, like a lot of people just want to, what we really want is like, how do I fix my car's light bulb in the back part or something like that? So this is a great way to get past the BS and get to a video. But this example is deliberately to show you that, hey, anywhere there's a video, you can grab it. Yeah, in the back.
Invidious has also been like getting shut down by YouTube a lot.
Invidious has been getting shut down, yeah.
Trying to use it, it just says, go to another Invidious instance.
Yeah. Yeah, it's so the, yeah, I that's what I've seen too. At the YouTube side, they appear to be blocking it in different creative ways. This is fine. We don't need them. So yeah, so the cool thing here is that I'm sorry I don't have a Jellyfin server running, but what I did was it's just vanilla MeTube. So MeTube, the way you get it, I'm just using the image. Okay, MeTube. Okay, so here's the thing to set up MeTube, and then let's simplify it for now. Okay, so that's it. To get running, this is all you really need. I have a downloads folder that I'm doing a volume out for, and I have this fancy little script. And you can plug in arbitrary code. You can run shell scripts, Python, whatever. In this case, what I've done is I've added one script that once it downloads a video, it's going to tell Jellyfin, refresh the library where you downloaded that thing right away. So it shows up in Jellyfin instantly. And in fact, I think if you have Jellyfin open, you'll get a push notification to your client, and it'll say like, oh, a new video has appeared. Do you want to watch it right now? So that's just kind of a great way, because you can watch it right from MeTube. Max showed me this morning that you can just click this, and it should, yeah, so it should play right there.
Oh, that's awesome.
Which is sweet. But Jellyfin's kind of handy. Like it shows up on our TV because we got a Roku app for Jellyfin or something like that. So what I wanted to happen was that it refreshes Jellyfin, right? Oh yeah, and Jellyfin's a little slow to refresh. It does have fnotify running, so it'll detect when a new file is added, but it's a little slow to pick that up. So what this script does, this big chunk of JSON says post processor. So when you get a video, go ahead and run metube Jellyfin. Okay, and that script quite simple. It looks a lot messier than what I'd imagine, but basically this is the whole secret sauce is right here. Just hit Jellyfin, telling it to go ahead and refresh, and then the special things are the library you're gonna hit, and I have a comment here telling you where to get that ID, and then I think I figured this out just by opening the developer console while I was in Jellyfin, and I hit refresh on a library, and then it sent this post request, so I just rewrote it to run in curl. You can even like right click on a web request you see like that in the developer console, say give me the curl version of this.
Jellyfin has an API too.
This is Jellyfin's API. So this is this is their web REST webhook for refreshing a library. Yeah, Jellyfin's API looks pretty sweet. I don't know, but that's the kind of the thing about this self-hosted stuff. Everything has an API. Everything that's at least slightly mature will have an API, and a lot of the new stuff they do the API first. So even the web client is using the API. It's not like CGI or something silly like that. It just seems very common these days that the client's behaviors will converge. Does that make sense? Yeah, I mean that's been a really fun thing. Like, if you want to bet one thing on your tech, if you happen to be in a tech career and you want to bet your career on one thing, bet it on HTTP. like if you mastered that protocol, you'd be like, anyway. So okay, so this is like integration I wanted to demonstrate here was metube plus Jellyfin. And okay, let me cover these really quick. So anybody using Gatia or ForgeJo? Yeah, okay. So why do you run a local Git server? Anyone want to share? Okay, no, why not?
I do it to post the stuff that I'm like bleeding edge, new, that I've got crazy ideas. I put it up on my own instance initially. That's just for me to consume, but others to make it accessible to others who want to look at it. But it's not meant to be necessarily worked on by others per se, other than just I have my own instance for my own projects that I start, and anything that goes beyond that, then I move it out to like Codeberg, for example.
Okay, so yeah, I do the same thing, and I'll try and repeat your question by way of summary. I set up a Gatia server to just like have a way to quickly get my own stuff on a server besides my laptop. Copy of it, another clone, and I don't want to need to share it anywhere. Like I'm not ready to share it or don't want to or whatever. But now just a year or two, and I have 150 little repositories on there, and there's no. Yeah, I don't even think about it anymore. Just put.
Right.
And the thing about Gatia is that the governance changed, I believe. So check out ForgeJo if you're running it, and do it fast if you are, because I think there is a.
They did do a hard fork, yes.
Did they already?
Yeah.
Okay, so a hard fork happened, so it's gonna be a little harder to migrate now. But just so you know, that's going on. ForgeJo's, I don't know, and like I looked at Gatia, I was like, are they doing anything untoward yet? And I couldn't. I'm not going to keep tabs on it, and I trust the governance of ForgeJo a little better. I think they started a foundation. But this is like really core. Like I'm tracking every line of everything I write, and there's no cost to do so. It's just boom, 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 push another code, make a new repo, push another thing. I have a copy of everything I work on. I'm like, okay, I'll always have a copy of it local. In my ForgeJo. So Redis changed governance as well. Right? There's some kind of rug pull. I'm not really following, but I'm like, fine. How hard is this? Well, it turns out one-liner to replace your Redis, Redis, whatever, anywhere with Valkey. And Valkey is sweet. It's supposedly faster to, I don't know. All I cared about is like, okay, drop-in replacement, governance looks better. Free software win. I think that's good. I have 5 minutes, anybody? Is that right?
7.
7, thank you. So those are 2 upgrades I wanted to mention. And again, for more of these, a great place to keep on top of these, I'm going to give another plug for Ethan and self-host, SeLFH. Like he keeps track of changes like this. Okay. Another one I'm not going to demo, and I think it's interesting to talk about because it's a little controversial these days, is running your own AI or just using AI in general. Generative AI is such a thing, isn't it? But I think as tech people, we need to understand it and understand the landscape, what's going on, keep tabs on industry trends and all that, and AI is a part of that. So love it or leave it, we should probably try it. So local AI, I don't know if this is the best one, and it's open source at least. It's free software, I think. And they get, it grabs models for you, it sets up an API server, and you can start using basically every kind of modern AI tool. So generating images, chatting, summarizing, speech to text, text to speech, on and on and on. So all the kind of cool things you can do today, you can do them all locally. And you can hit most of them with one line, Perl, Python, whatever. And if you have an xCloud server running, for example, it's built to run with the proprietary AI services, but you can also just point it at local AI. And it works as well as those models work. The models, I believe, are not, I wouldn't call them open source. I think, if you're trying to figure out, you can't, I don't think you can reproduce what the models do or rebuild them yourself. That would likely be very challenging. Some of them, it might be impossible because you don't have the source data or the build them. But you can get the models. You can try these things out. It's worth it. I mean, I don't know. Yeah, it's just like people are using the proprietary chat services. So like, I think it's upon us to know what's going on with this stuff. So, but I end up using my local AI server for what did I search for today? I was like, oh yeah, why is PID1 special in Linux? This is like computer science 101 from the 80s, or 60s. Like PID1 was a Minix concept. Linux took it on, Unix even, maybe even before Minix, but it's in there. So like the model, the source data includes so many times people talking about PID1 and Linux and blah, blah, blah. So I can use local AI like a search engine. Oh, tell me about Linux. Tell me about PID1. You just keep asking questions. It changes the way we learn and the way we write code and all of that. So worth checking out. And this integration is a particularly smooth one. Just kind of works. Any questions about that? No comments. I won't accept comments on AI. Okay. Change detection IO. Let me come back to that. DocuSeal. So this was a fun one. This is where so if you want to get a piece of paper signed that's a PDF, you got to use one of these proprietary services, and they're just silly, drive me crazy. And it's like, is that legal? Well, it turns out a PDF signed by a little image that looks like your signature, legally binding. Absolutely. So, and these folks they'll explain it on their website, and maybe it's correct, probably. But we've all been using e-signing for quite a while now. Now you can run your own, quite simple. I pulled this thing up and I was like, why is there a little GitHub badge? I just started it up locally and there's a GitHub badge. I'm like, that's weird, on my own self-hosted one. I mean, I understand the service they run, and I'm like, oh, that's for tracking. They're pulling the number, how many stars, whatever it is, I don't care. But I said, hey, can we just get rid of that? It turns out a bunch of other users that also asked, hey, can we just get rid of that, please? I don't want the tracking badge and I don't want it reaching out. Well, and there's stuff like, well, why don't you just block outbound traffic to that place, and I'm like, I don't want to have to do any extra work. Like, okay, I'm gonna hack this thing. And so I found out where it was. I went down the rabbit hole and I took out 2 lines of blah blah blah, grabbing the image, and then I forked it. But my fork is just like, edit these few lines, and now I can, and I just keep pulling in upstream, merging in upstream, run my little fork. And anyway, I don't have time to walk through it today, but I posted about it online. I shared far and wide how, hey, this is great what they're doing. I think it's a cool app. Here's how to customize it if you don't want that feature. And I got mostly praise. I mean, a couple people were like, you don't understand what a phone home is. And I'm like, okay, thanks for explaining me to myself and all that. But in short, you can do this. It's not that hard. Ping me, I'll help you. And you can see the stuff I posted online about it. With Docker, it's so easy to do mini forks and mini customizations and tweaks. So have at it, please. Any last comments? Yeah, in the back.
How system intensive was local AI to run?
Very. I bought a GPU for it. So, and I would highly recommend a GPU. Yeah, because like chatting is always like, it's high. It needs a lot of VRAM, and stuff has to load in and out of VRAM, which is a CPU intensive. I don't know. Like it's slow unless you got a horse. Yeah.
With the various models in local AI, could you run it on a box that's entirely isolated from the public internet?
Yes, completely offline.
Huh.
It's cool. Yeah, so local AI and Nextcloud can be used. Okay, that's all we got time for. I will take questions after. If you want to come up, please, if you got a book, please grab one and then tell me about it. And then I want to make sure and earmark the sales today for SeaGL. And thank you.
Thank you.
Yeah,
please. Thank you. Oh, good. I gotta get out of the way. You're awesome. Great coat. Cool.
length of a Harry Potter book. Right? Think about the scale. Think about the number. It's interesting. Now, I personally believe that the answer I have in the title is very obvious. I think it's yes, for sure. Now, another statement I want to make that is if you build any modules, functions, you design any APIs, and your API adoption rate will highly determined by how well the large language models can use it. All right, so the better you build it for large language model, the more benefit you will get from it. Now, the real question actually is how we, as developer, open source contributor, how do we enable large language models to generate high quality code for your projects? Everybody should start thinking about this. And I have some really initial thoughts I want to share with you in this talk. There's two ways we can teach, quote unquote, AI how to, or learn, particularly large language model, to use API. For example, one way is through training. We have an algorithm, right? Widely used is transformer architecture, and then we train this model with extensive amount of training data, including project source code, including code examples, including documentations, a lot of things, all text. Just dump into the training process. Once you finish the training, you can actually do zero-shot prompt. Basically, in the example, you say, hey, how to read a CSV file with pandas. If you are familiar with Python ecosystem in the data science community, you know pandas is a pretty well-used open source framework to process structured data. And without anything, without any prompt, without any explanation, generate that code. Which means the AI already internalized all the learnings, all the knowledge about pandas, that library. Also know how to write proper Python script, right? So everything is done through training. The training process uses a lot of data, right? That's very, very friendly for existing established project like pandas, like well-known product like React. Okay, if you estimate how much tokens or how many text we use for training, it's about 100 gigabytes, roughly, for using React framework as example, right? In the repository, they have 50 gigabytes. You just add up everything. You have 400 gigabytes of text data. In the training process, eventually you get AI very good at creating React code. You have a similar amount of text input to about pandas or Python, then AI know how to use pandas and Python. The bad news is, the good news is, we already know how to do it. That's why AI is very useful to creating those code. The bad news is this: it doesn't really can apply to a project. Haven't gained any popularity yet. Simply, you don't have that many of text generated around your program, your project, or your API. Because it's new, there's not too many bloggers write about your project, about YouTubers talk about your project. There's not too much ecosystem related packages, and there's not too many things. All you have is your source code plus some documentation. Okay, so even though AI may grab your documentations in their training process, the chances are the weights in the large language model won't be impacted too much by you small portion of your projects. So how do we deal with it? And then we go to the second way, and then we have to talk about the second way, another way to teach AI how to do it. Actually, is from field shot learning. Before that, let me introduce this type of concept. It's called large language model oriented programming. Here it is. So we're gonna admit that the projects that can maximize large language model contributions can gain a competitive edge. No matter if you do company internal projects or open source project, you can make your project can be easily generated by AI. You can let AI contribute to your program. You can let other people use your program better. So, and the proposal is this. So, large language model oriented programming actually is a development framework that focus on facilitate effective field shot learning. We're going to talk about the field shot learning in a bit to enhance code generation accuracy. Okay, I'll give you some examples. This is actually new project friendly. If you have a new project, you want to let people use it, this is probably the only shot. So what is field shot learning? So first of all, you give AI a single comprehensive prompt, and then let AI generate what you want. And it doesn't require too much round of communications. And it also, very important, there's no model weight change. There's no fine tuning, no training process, simply because we don't have that much of text for AI learn in the training process. Here's an example. For example, you have in your code base, you have this function, get user data, and have two parameters you need to send. One's user ID, one's company name, or company ID. And what you want is, hey, I want to that can determine if a user belongs to a company. Right? This is a very simple example, and let's see how it works. On the left-hand side, this is your prompt. So in the prompt, it's very small font. I intentionally did that, so I don't want you to read through them. I will explain this structure a little bit in the next slide. But here's the result. You have this prompt you send to AI. AI will generate code, right? AI will help you to create that new functions. This is exactly what you want. So if you check this prompt structure, actually, 3 parts. First of all, is function definition. Tell you, hey, function names, parameters. The second one is instruction. So what kind of things you want AI to know about this function, how to use this function? In this example, you have parameters names. Right? You have the behavior of this API. You describe, hey, what return values you have, and then how to handle errors, right? And some code examples, how to use it, and then some special notes you want AI to know about this specific functions. If you want to go fancier, right, you can also add debugging strategies. None of these. You have just long paragraph of text you want AI to know. Then you describe your task. Hey, generate that new function for me. I want a new function if users belong to a company. So there's 3 parts of your prompt. If you have one prompt with this part, hopefully AI will follow them, learn from this learn from this prompt with few shot of examples, and then know how to generate the code with high quality. So here is the workflow when you generate code. Actually, you start with a task in your mind, and you want to tell AI, or you want to tell the tool, hey, I want to do this. Then you let the tool to grab the correlated or related information from your code base and form it to a prompt. And then you send the prompt to AI of your preference, and you get the code back. Okay, this is a simplified workflow. And something in the middle is called RAG, called augmented generation. Okay. So this is widely used in the AI application space, chances that if you use any AI system nowadays, large language model based, there's one or several RAG pipelines behind. Some of them can be very, very sophisticated. They can grab one piece of information and trace back to another piece of information and grab in parallel. Some of RAG systems can give me a question and I check whatever information I have in the database. Answer. Nonetheless, this RAG pipeline should be there to help us generate that prompt. And the higher quality of your RAG, the better of your code quality. Because you have enough information, you have enough signal to noise ratio in your prompt, AI should learn from, and then you have better chance to get better code. Okay? So our large language model oriented programming design principle is very simple. Let's prioritize RAG, recall, and precision, which means accuracy. Okay, let's make it any RAG pipeline or some simple RAG pipeline to easily retrieve the code information instruction you have in your code base. If you want to know how to use one function, you just easily retrieve all the functions, all the related information from the function. In this case, we don't have luxury to embed all the learnings in the weights in the large language model. By doing this, it's workaround to teach AI how to do it. Okay. And then when we develop new functions, it's good habit practice to write documentations, right? Sometimes we write docstring, sometimes we write another piece of code to render as documentation. And in this case, we need to write documentation for large language models, not for humans. I will tell you the difference within a little bit. And then we also need to constantly test a piece of documentation we write, code base we write, and make sure that, hey, whatever we put into the code base is helpful for AI to generate high quality code. 3 best practice. Number 1, as we said, hey, we want to prioritize RAG accuracy. Now we need to spend more time than ever to come up with very good names, descriptions. In the past, I know 70% of our developer time is figure out what a name is good for my project, right? For my API functions. Now we need to spend more time and not only think about what we do, but we also need to test if the name description are good enough. As we all know, RAG is based on similarity measurement, which means, hey, they will embedding your text into a very, very long vector, and eventually every piece of information in your code base will become a vector. And you want that every single, if you have 2 different functions, you want them to be present in the vector space in a different way. You don't want to have 2 functions, but have 2 different, you have 2 functions, have 2 different features. You don't want them to look like similar in the vector space. Okay, so this is why we need to use embedding model to test this, to measure distance between 2 sets of functions or one function versus every other functions to make sure that they're actually right. So number 1, number 2 is we need to write documentations for large language model. I'm going to spend a little bit more time here. So if we write documentation for human, we believe a good format, a good readable format is important, but turns out AI don't care that much about formats, right? Sometimes you want to keep it simple. You don't want to spend so much time on very complicated the examples. Those are not applicable now for AI. Let's go one by one. You want to write very direct instruction to AI in your documentation. so AI can learn. And you also want to write some don't. Hey, this is what you do. This is what you don't do. Okay, we normally don't do this to our fellow developers. So, but here you will do it here, and then you don't cross-reference different parameters or function name. For example, if I have two functions have a similar set of parameters, sometimes we just want to keep it simple. Hey, see the other functions for the parameter's name, similar type, they're similar meanings, whatsoever. But you don't want to do it here, simply because when you retrieve this piece of information, the RLG may not be smart enough to figure out, okay, actually I need to go to another function to that information. You want the entire information is self-contained in one piece of text you send to you created along with these functions or APIs. And third of all, you want to give a lot of examples. I know when we write documentation for human being, we don't want a lot of examples. We trust human can do it. And then if we have a lot of examples, we put them in a separate page, right? We have a cookbook, we have other things, we have blogs. But here you want to add a lot of examples here. And including some very complicated ones, or maybe even some false ones. You say, hey, this example is this a bad example? Don't follow it. This will lead to error code. This will lead to another error message, something like that. And also, I know sometimes you have architecture diagram for human to learn why this designed that way, why I need to support this, how this integrates inside your system. But in this case, you want to convert them into text for AI to consume. Basically, large language model is based on. However, this may change very soon because very soon we're going to use a lot of multimodal AI language models. AI capability of reading diagrams may be improved, and then we no longer need this. But for now, still quite important. Practice 3. We want to constantly test if our created functions, names, parameters, instructions are good enough to help the code gen. So we want to create a lot of tests, including the task you want AI to complete, and then the generated code. And you want to figure out a way to benchmark them. Hey, how many errors AI can give me when I ask AI to generate something based on this API. And you want to make it part of regression test. In the past, when we change one thing, one functions, there's a lot of unrelated function. We think we can skip those because this function is so isolated, won't touch other things. However, here it's a little bit different because every of your function is in a vector space. You change one thing here, you may just impact other parts of the space. You want to be a little bit careful. So that's why always run it in your CI pipeline if possible. Your CI pipeline also need to be robust enough to be able to send the request to AI, wait for a little bit longer. And so how to design your CI pipeline is very tricky. Yes. I believe there will be some open source frameworks to be created in this space. Okay. Now, if we have those space, actually this can actually enable this. You have a good retrieval quality, and then you can have a good prompt, and then you can generate good code. Right. Last but not least, we can go very, very fancy in future, including sometimes we cannot generate correct at the beginning. We need a debug flow. So actually, this large language model oriented programming can also ensure that debugging flow runs as smooth as possible. Okay, so quick recap. Thank you for your time. Okay, I'm ready for some questions. Thanks.
Yeah, you said this is a framework. Is there something you need to pull in, or is this just like a way of? I'm sorry, can you hear me?
A little bit.
You said this is a framework. Does this require some sort of dependency, or is this just a way of modeling documentation within your code to better use LLMs to ingest it?
Yeah, the question is there any dependencies if you want to adopt this network? And now you have to manually set up a lot of pipelines, a lot of you have to figure out your best practice. But I hope there will be open source framework or some sort of framework you can import, and you can start to have even notifications or instructions how to do it, and then maybe also check the quality of your documentations, set up the pipeline for you to test your code gen capability. But that's a very good question. Yeah.
For your tests, how many of those are AI generated, and how many of those are you creating manually?
Good question. So for the specific, the question is, for this type of test, for AI-oriented programming test, you want to test them manually, but you want to figure out a way to evaluate results automatically, because the result will generate it. Either you get a code, but the code can be generated differently, but they have the same function. You want to use some AI to really tell, hey, if this code is, or maybe you can have runtime running behind and check the result, and if you observe that result, if the result is right, you assume that generated code is correct. But this is very open field. There's a lot of things to be done to make it. Yeah. All right. Hey, thank you very much, everybody. Pleasure.
You can wait until 2 and start doing it, but it's like.
Okay.
Thank God. So,
Hey, there it is. Now, Keynote, everybody. Proprietary software that makes pretty pictures show up on the screen. Hi, good afternoon. My name is Tristan Damron, founder of the GeoCamel project. Today, I'm going to be presenting on GeoCamel-based deployments, what they are, how to use them, and so on and so forth. Hope you all had a great conference. Down on presentations and start moving into social activities. I will give you all fair warning. I'm going to go pretty quick through a lot of this stuff. There might not be enough time for a Q&A at the end, but feel free to catch me at TGL or any of those other social events. We can chat if you have questions. If there is time, I'll try to fit you in. So, before we get started, I wanted to poll people here in this room and ask who here has any experience or knows what GIS is. Okay, oh my gosh, way more people than I thought. Don't raise their hands. Who here has experience with enterprise GIS deployment specifically? Okay, less, but some idea. Okay. So for those not acquainted, there's only a few of you. What is GIS? So we live on a complicated, fragile, and ever-evolving planet. At any given moment, there's a tremendous amount of data around us between man-made structures, geographic and geological marvels, and hydrographic wonders. As humans, we often take for granted how common these features are in our daily lives, and it is easy to forget their greater significance on this planet. Geographic Information Systems, or GIS, allow us to collect, store, and manipulate any geographic data, empowering us to understand the world around us. Through the marriage of geography and technology, GIS technologies present us with an opportunity to view and by proxy change the world around us using a data-driven approach. So generally, this is what GIS is. What about enterprise GIS? What do we mean when we talk about GIS in the enterprise? Well, in a typical enterprise GIS, it starts by collecting your data. This could be like satellite imagery or collecting on-the-ground features. The collected data models real-world features on the surface of the planet. Land parcels, buildings, vegetation, or really anything on Earth that these data are then stored in a database, often connected to a server, where that data can be shared over the internet for use in web, desktop, and mobile applications. All of you, whether you know it or not, have benefited in your lives by GIS data, and I'm willing to bet that everybody here GIS data to get to this meeting hall today. Whether you were looking up where the hell is this room, or, you know, how do I get to UW? How do I get to Seattle? I drove up here this morning from Portland, and I used GIS data to map my whole way there. So clearly, this is a very pervasive, present, powerful technology in our lives. But there's something that I need to tell you. An admission, in fact. Enterprise GIS has problems. More specifically, I think it would be accurate to say something like, enterprise GIS has big problems. What are these problems exactly? If you're already familiar with enterprise GIS, you probably have a good idea about what some of these problems are that I'm about to talk to you about. I, by principle, have identified 5 really big things that I think are either lacking in the industry or are really holding the industry back in a variety of ways. So problem number 1, doing enterprise GIS work is expensive. If you're using an Esri product, for example, ArcGIS, very common enterprise GIS deployment, you're going to have to worry a lot about user credits, maintenance fees, licensing fees, a whole lot of dough to spend in a very short amount of time just to get your data working the way you need it to across this enterprise environment. This is a really high financial barrier to entry if you happen to be a small organization, an academic institution with not a lot of projects, or you're an individual who happens to have quite a large amount of data, and you need to rely on an enterprise GIS to share that data with the world. Problem number 2, doing enterprise GIS work is complicated. There are too many independent services talking to each other, or sometimes they just don't talk to each other at all. So there are several commercial off-the-shelf options for enterprise GIS, but if you've worked in a GIS shop, you might have experienced weird homebrew servers that don't really talk super well using very old API protocols, and getting all this stuff to work together can be a nightmare. Problem number 3. There is nearly no accepted standardization for similar geographic. So on this slide, you can see 2 layers. And when we say layer, we're talking about the visual representation of some table. So the bottom shows city streets here in Seattle. And then the top one shows city streets in my city in Portland, not too far from each other. And you can see the attributes for each of those layers. So take a look at the Portland data set up top and look at the road name column. Road name, that field is appropriately named road name, and it shows road names. And not to diss on Seattle or anything, these are official government data sets. You can download them at your own leisure. But unit description is the field name that describe the same thing, road names. Now, let's say you wanted to create a regional roadway data set that combines data from everywhere but from Portland up to Seattle. Using these 2 sources, it's going to be a really huge problem because you're talking in 2 different languages schema-wise. You're going to have to make a lot of compromises in a lot of different ways in order to make these things interop with one another. Wouldn't it be great if we had a situation where database schemas were shareable and consistent? That would be great. Problem number 4. The right data set is hard to find, and when you do find it, it's going to be pretty expensive. You're going to be willing, you better be willing, to shell out at least a couple $100 for really good data just to license it. Or if you want to access something over an API, get ready to shell out, some amount of money, probably a subscription these days, for some API key, right? There are aggregate sites that make data harder to or easier access. But again, often those aggregate sites charge a lot of money. So again, it goes back to problem number 1 a little bit, but it's big enough that I think it stands on its own. Problem number 5, the final problem, in my opinion, this is the biggest one. North American and European markets are primarily using proprietary GIS software. They have a major dominant market share in this region and in Europe, and it's growing in the global south and Asia, where free and open source software products, like some of the things we're going to be looking at today, are actually more dominant. So this is a huge problem if you're a free and open source software advocate, but not a problem if that's the president of Esri. He makes all the money. So how long have these problems existed? Who wants to take a guess? How long? Sure.
40 years.
40 years? How about forever? It has never not been a problem in this industry. And yes, it is true. That is a very long time. If you've ever waited for forever, you might know just how long that actually is. And as an industry, we really have been waiting forever. So these 5 problems eventually culminated in my mind, and I said, okay, we got to do something. There's nothing out there right now that really solves all of these problems or is trying to solve all these problems. There might be products that are trying to solve one that might work with another product or maybe not. There's nothing that is all-encompassing. a true solution to these issues. So, about 2.5 years ago, I started the GeoCamel project, inspired by Sean Marquette. To do it, I had been thinking about it for a very long time, and he said, why don't you just do it and stop talking to me about it? And I said, you know what, you're right, I should just make it. I'm gonna talk to you about what this means. So GeoCamel, obviously there's an acronym in there. The camel, CML, I know you're gonna see a lot of animal names without vowels today. I'm sorry, it's just gonna happen. The CML stands for containerized, multi-paradigm, lightweight. Okay, what do each of these actually mean? So I pulled this right from our website at geocamel.com. So containerized, we use Docker and Ansible to configure all of your GIS, every single aspect of it, right out of the box. And you're welcome to customize that if you would like. If it doesn't out of the box do what you need it to do, it's all free and open source software. So go ahead, change it. GeoCamel is also multi-paradigm. So when we talk about paradigms in GIS, we're really talking about 3 tiers. We're talking about GIS, which is using like QGIS, which is a desktop application for analyzing or manipulating data. One level higher than that, server GIS, which is using APIs to transmit that data that you GIS to other people around the world. Usually for the purpose of copying a data set and using it in your own GIS, typically. And then finally, the web paradigm, which is what most normal non-technical GIS people are going to be interacting with. This is as simple as a web map on a website, right? So or any app on your phone, right, that pulls some kind of server data. That would technically qualify under the web GIS paradigm. GeoCamel is also lightweight. There's that L. We finished the acronym, but there's so much more. So lightweight, what does that actually mean? Well, if you've deployed some of these proprietary enterprise GIS, you will know that it requires overhead on your server, at least 20 gigabytes of space per machine, even if you don't need a fraction of that for your data set. It happens to be small. Upwards of 8 to 16 gigabytes of RAM right off the bat, which a lot of people, again, financial barriers, can't afford that. GeoCamel does a lot more with a lot less. I'm going to show you an example today of a GeoCamel deployment running on a Linode machine that is 2-core CPU. I forget the clock rate, but it's low. And 4 gigs of RAM and about 20 gigabytes or 10 gigabytes of space. And we could go a lot lower, but I just went with the first thing that popped up on Linode's website when I made the server. So, but it could go down as low as possibly single core and as low as 2 gigabytes of RAM appropriately. We talked a little bit about how it's customizable. So we can, because it's free and open source software, you can change anything in these Docker file definitions or use Ansible to really, at a higher level, manipulate what's going on in these containers to really fit whatever use case you need. Every deployment's different, and GeoCamel-based deployments are not always going to work for you right out of the box, but we support and totally encourage people to make these customizable for your needs. Is there a question?
Just quick comment. There's also a size constraint on GitHub Actions.
Oh yeah.
How big of a image you can host there. So we're also lightweight by virtue of necessity.
The free tier, everybody. We don't pay anything for our hosting on our container registry. So we talked, it's open source software, but not only is it libre software, it is also gratis software. We're not going to come knocking at your door asking for money because you're using GeoCamel in some way. Just use it. Do your life's work in GeoCamel. That's great. And if you happen to want to maybe push upstream, if you make a really good change, please do that. But not a requirement. We don't have an upstream. It is all licensed. Everything you're going to see today licensed under GPL v2. So keep that in mind. So this is at a high level, like what the heck are we even talking about? Let's go a little bit more granular and talk about GeoCamel platform, which is the individual software components that make up a GeoCamel base deployment. So there's 6 things here, and we can kind of separate them into 2-ish groups. So the first group is the actual GeoCamel base deployment. So each of these components represents a Docker container running on a server. So in blue, we have GeoCamel desktop. In orange, right to the next of that, the database icon, is GeoCamel Postgres. And in green, GeoCamel Task Scheduler, we sometimes call GTS because it's kind of a mouthful. And GeoCamel Server, finally, in the dark red-orange. So in each of these, when we say we're in GeoCamel desktop right now, what we really mean is we are working inside of that container. We say we're inside of GeoCamel server, we're inside of that. Whereas there are 2 separate projects that interop very well with your GeoCamel based deployment, but are not necessarily containerized in the same way. For example, Tabor, a database modeling language for geographic data sets. That's just an executable. It's a transpiler. Translates Tabor files in its own syntax into a bunch of PostgreSQL queries and loads your database a little bit. And Dragon, again, how's going on here? Dragon, which stands for Distributed Registry of Geographic Information Systems over a Network, is essentially like a search engine for GIS deployment, specifically GeoCamel deployment. So if you were looking for that great new data set, don't know where to find it, we have an API for you and a little bit of a user interface as well. So I'm going to be very brave and I'm going to do a live demo because I feel like just talking about this is boring and not really. So give me one moment. I have to switch from an extended display to a mirrored display so I can see what I'm doing. Okay. Can we see all this? Is this looking good? Let me just, we're going to be in there in a second. Okay. So I don't know if you heard, there was an election. Maybe you heard about it. So I thought it would be very topical and nonpartisan to just look at raw data counts because like people have feelings and I totally get it. I don't want to like get into that right now, but I think we could still look at just raw coming from this election. So here is GeoCamel server portal, and it is hosted right now on 2024voterturnout.com. And this is a representation of what GeoCamel can do in the WebGIS paradigm. Recall, WebGIS paradigm, for those who don't know, is accessing for the layperson some data set. Really, it's a read-only data set. So you can see here on this portal, which by the way is all like pre-configured, and I'll show you how to like change certain things on it. You don't have to be a coder or know any HTML to do any of that stuff. But you can see we got a description of the project. We have title, some contact information. We have some layers down there. We'll talk about that in a minute. But we also have this view project as web map button. So if I click this, I get to my world map and I can zoom in on this data. This is all powered by Leaflet, if you're familiar with that. This is sort of our, just our front end for this. So a couple of interesting things. We're going to talk about the data a little bit. I just think it's kind of interesting. So as we're looking at this data, we can see which layers we're looking at. So we're currently looking at the world map, which is checked, and voter age population turnout. So this is the percentage of people who are of voting age who actually vote. So some interesting things. Those blue wall states that we all heard about during the election had I don't know like what party. Again, this is a nonpartisan data set, just raw counts. So did North Carolina. However, 2 other swing states, Arizona and Nevada, currently, according to projections, and there's still ballots being counted, this will get updated, they didn't have quite as high of a turnout, which is an interesting thing that you might glean from this map. There are many interesting things to glean from this map. For example, why does Florida look like that? That may be on your mind as well. Now, what's cool about GIS, all these data layers, right? And we can compare data layers visually in the WebGIS paradigm. So for example, if I wanted to compare this voting age population turnout map to eligible voting population, I'm just going to enable that layer and disable the layer above it, and we can actually see who, as a percentage, here we can see in the legend what these colors actually mean, who is actually eligible to vote in this election. You see, and it's all normalized by population. So even though Montana and West Virginia look really high, I swear they're actually pretty high. So you can see some interesting trends there. There's a lot of data in this data set, and I encourage everybody after this, if you're really interested, take a look and see if you can find some relationships, maybe something to talk about with your friends. But I wanted to use this as an example just to kind of show you what GeoCamel can do. Zero configuration went into making this map. All I did was I made the map and it showed up on my portal. Pretty cool. So let's get out of here for a second. So we just looked at the web paradigm. Let's look at the server paradigm, right? So when we talk about server, again, we're talking about using APIs to transmit data to other geographic information systems for using that data in their own project. So GeoCamel server, the container that we're in right now, has web mapping service capabilities, web graphic feature capabilities. So these three buttons here, web map service means give me the whole map and nothing but the map. Web feature service means give me the layers and the data that. And web cartographic services would be for requesting specific raster data. We don't have any of that in this data set, but that would look something like satellite imagery or maybe like bathymetry data, something like some kind of image that you would put on a map. So if I wanted to get that, all I would have to do is, let's say I want to get the whole map and nothing but the map. We're on pretty bad Wi-Fi here, unfortunately. But if I click this button, I'm going to get a whole bunch of XML from QGIS server. QGIS server is the primary component that runs this paradigm within the GeoCamel server Docker container. So if I wanted to use this in any modern desktop GIS platform, all I'd have to do is copy this request exactly as it shows up here, paste it into whatever WMS importer I'm using on my application, and I'm going to have the whole map, which is pretty sweet. Similarly, if I wanted to get all layers, I would do the same thing, but with web feature services. But sometimes, as we said, there's a lot of data here. I might not want all of that data. I might just like want one layer, right? Hosted layers, just underneath of that, allows us to do that. So if I click on any of these buttons, I'm just going to get the specific API and for one of these layers, and it will return to me the whole table of information. Because there's so much data here, if I actually open those up right now on this poor network connection, it's going to take forever. So you could try it on actual Wi-Fi. I'm skeptical of Wi-Fi security at the conference, so I'm just my phone as a hotspot. So I'm not going to click it, but please do if you're feeling brave. And then finally, on GeoCamel server portal, we can see at the very bottom, we have this. I just added this like literally right before the conference because I thought it would be good to show how Dragon works. So you see here, explore similar data sets, results powered by Dragon. So Dragon, recall, distributed registry of geographic information systems. So what is happening here? Well, GeoCamel server is communicating with Dragon via an API and finding recommended similar data sets that you might be interested in if you're looking at this data set. In this case, there's only one similar data set, and it happens to be the same one. That will not show up in future releases, but since there's only one, I thought I'd include it. So yeah, really powerful. You'll see up to 10 recommendations by default. You can configure that on your own in GeoCamel server portal. So where does Dragon actually live? Well, we have a public registry, dragon.geocamel.com. This is our REST API. For example, if I just query the registry to get everything, just a simple GET request, I can see this is the format of that. If you want to actually register, there is an API key that you need. It is 100% a ridiculous amount of stuff on this registry, or like things that are not GeoCamel deployments. We have checks in place for that. So when you go home, if you're interested in doing something with GeoCamel, you know, pull our containers and you put it up somewhere public. It'll show up here, and your contributions will be added to this greater registry of data. Hopefully, create a really powerful, healthy ecosystem for geographic data, which we don't currently have. So this is both the web and server paradigm. So where did this data actually come from? Well, it comes from the University of Florida's Election Lab, which is like online, but it was prepared into a map inside of a desktop. So we've talked about GeoCamel desktop kind of in a couple slides ago. Where is GeoCamel desktop? How do you actually change this data? How do you manipulate it? How do you analyze it? How do you classify it? Well, I have this tab here, 2024voterturnout.com, port 10,000, can connect to this password protected X session, X basically. And I can access QGIS desktop straight from my web browser, which is really cool for two reasons, obviously. But the first reason is it is super portable. So I can use this desktop class application on a tablet or on a mobile phone. So if I'm like out in the field and I'm like actually collecting data, I don't have to worry about going to like ArcGIS collector or whatever and like loading all that data. I can just do it straight into my tables right here. Really cool. It's also like works very well on low bandwidth. I can just like pan around here. It's buffering, so just give it 1 second. But relatively good for like a 4G connection, I think. And also, another cool thing about it is because it's containerized and connected intrinsically through a Docker network to all of your other containers, everything that you do in GeoCamel desktop in this QGIS desktop application is going to have an effect on all of your other containers, and it's all just going to update seamlessly. You don't have to worry about anything. So I'm not going to give a very detailed what is QGIS and how cool is this thing, because that could be like a 4-hour talk that nobody wants. Nobody here is drunk enough to want to hear me talk about that for 4 hours. So, but maybe at the social hour you will be. So what's actually happening here? I'm just going to give a rundown of a couple of really cool things that differentiate this desktop interface from like the web interface. So, for example, whereas our web interface totally read-only, this data set is 100% writable, right? So if I want to reclassify this map, like, I don't know, I want to change this from blue to green because I'm a crazy person and I think that looks better than whatever I just had. And I save this project and I go back to GeoCamel server portal, refresh the page, wait for it, boom, there it is. That was as easy as it is to classify your data. Any change I make in GeoCamel desktop in QGIS, it's just going to pop up right there and you don't have to. Other cool things that I can do. First of all, I'm going to bring back the blues. Thought it looked much nicer. Symbology is important. So another cool thing you can do, again, this is all writable, so I can open those tables we were looking at, like in the slides before, we looked at the Portland and Seattle streets data set. And I can make changes. Like, for example, like I don't have any voter data on American Samoa, but like I have here, or that feature in this layer. I can just go in and delete it and then save it. And American Samoa is gone. Sorry. We can bring it back too, just to show you all this is writable. Or if I could add a new column to here, I could even go so far to use a field calculator to like automate the processing of what those fields should be. You know, so if I want to have some equation that's like, okay, this new field is some aggregate of fields X and Y, I can There's a lot of powerful things. There's like geoprocessing tools, which actually I think for legal reasons, geoprocessing tools are Esri specific, so I should call them processing tools. And a whole bunch of really cool stuff, as well as a really robust ecosystem of extensions, free and open source in almost every case. But again, we're not going to go. So if GeoCamel desktop running QGIS desktop is where this data actually gets prepared and whatever, where does it live? It lives in GeoCamel Postgres, which hosts a PostgreSQL database with PostGIS enabled. PostGIS is just an extension on PostgreSQL. Now, within QGIS, I can connect to that. So I've already done that. I've already connected to GeoCamel Postgres. And if you take a look just like very quickly, if I edit this connection, you can see the host name and everything is just GeoCamel Postgres, because again, this is all a internal network within Docker Compose, right? So I don't actually need to host this separately. It's already hosted on this one single machine. So I don't have to worry about any of that crazy. So you can see I have a schema called public, and there's 2 layers in this schema, US states and territories and some world map, GIS. And you may be thinking to yourself, wait a minute, I have, what, 6 or 7 layers there, only 2 layers in the database. What the heck is going on, Tristan? Are you lying to me? And to that, I would say, no, I would never lie to you. Actually, what's happening is for each of these data sets, it's the same source of data. We just create multiple instances of it and classify it based on some attribute. So for example, voting age population is just US states and territories classified by voting age, and so on down the line. So we can kind of like optimize some things and not make a million layers when it's really the same data we're talking. So GeoCamel Postgres, a separate service that's running alongside GeoCamel Desktop and GeoCamel Server. There is one service, though, the 4th service. Who remembers what it is that we haven't talked about yet? Web? No, we've talked about GeoCamel Server Portal. So, good point. So the web paradigm and the server paradigm are both right. Task scheduler. What about the task scheduler? Well, the task scheduler, that's running on the server in the background. So in order to see what it's actually doing, you actually have to go into this Linode machine, which I've done here. I've SSH'd into it. And I'm just going to ls, the app directory here, and you can see this is just the base deployment that we have on our GitHub repo. I didn't add anything crazy to this except for the data set, obviously, that you're looking at. Everything that you're seeing here comes straight out of the box with GeoCamel, straight from our repository. So what about the task scheduler? We can see it's running. We do a Docker Compose PS. Yeah, there it is. But what is it actually doing? Well, to see that, we have to go into its source code. There's a little bit of programming involved for this, but once you understand the power of it, I think you'll be really impressed. Let's go into build resources, GeoCamel task scheduler, ls here. Actually, let's go into Vim, just because it looks prettier. So here we can see a bunch of Python scripts that are, is this readable to people in the back? Make it bigger. Is that better? Maybe? Okay, cool. All right, a little bigger? For the people at home, is that good? Maybe? All right, y'all got to get eyes checked. I'm kidding. All right, so we see here a bunch of Python scripts. Basically what Task Scheduler does is it runs Python scripts that you write, automate complicated or difficult tasks that you would have to otherwise do manually on some schedule. And we have a very simple API that creates that and allocates threads and things to make that all happen. You can see under schedule.py what comes out of the box with GeoCamel on a schedule, right? So these are all default tasks running all the time. The first one is backup GeoCamel DB. This one runs every hour on the hour, and its job is to take your entire GeoCamel DB and make a copy of it, or it has a backup, so that if something catastrophic happens and your server explodes and you have to redo all this stuff, you have some kind of backup file to work from. And that's going to happen every hour. We also have the restore GeoCamel DB task, which when something explodes and you restart your server, it's going to look for backup files, automatically bring back all your stuff exactly where it was before. We also have a task that is health checking all of the services in your deployment. So it's just pinging things within the Docker network to make sure that they're up. And then finally, the register with Dragon task. So this is the thing that actually talks to Dragon. So when you create your GeoCamel based deployment, and it's all valid, all the configuration and stuff is correct. We'll talk about that in a minute. GeoCamel task scheduler is going to ping Dragon and say, hey, Dragon, I am representing a GeoCamel deployment, and here's all the information about it. Dragon's going to go, is this valid? Yeah, it looks good to me. And then put it on the registry, and GeoCamel task scheduler is going to smile and make you very happy. This contributed to that larger ecosystem of good geospatial data. So yeah, this is the schedule. Let's take a look at one of those tasks just to give you an idea about like how simple and also how versatile they are. So let's look at register with Dragon. Pretty self-explanatory. It's a single Python function within a single Python class that we're just allocating to some thread every hour, 30 seconds, minute, whatever, however long you want to do it. And it's just going to run in the background. So if you have an idea, like your deployment requires some kind of automation that needs to happen every hour. For example, like you're pinging some external data set, right? You want to do that every hour and then save it to your deployment. Totally do that and just add it to the schedule. Really easy. So GeoCamel task scheduler is pretty rad. Let's talk a second about how GeoCamel server portal was configured. Kind of skipped over this. My bad. So where did this data come from? Yes, we know the data set actually came from GeoCamel desktop, but what about the other stuff? Like what about the description? What about this contact information with this phone number that's definitely real? Call it where it's real. Where did all that come from? Well, it also came from QGIS. So if I open project properties and I go to QGIS server, boom, I have a form of all of the information that describes this particular project, including description, title, contact information, who owns this, what's their email, what's their phone number, whatever, and the layers and advertised extent of those layers within the deployment. So you can see I publish all these layers. If I were to remove one of these, you would not be able to connect to it via web feature services. It's pretty cool. Now, this is just a QGIS feature that comes with QGIS and operates with QGIS server. So why is it so cool that GeoCamel is doing this? Well, it is because it's all hosted on a single machine. If you were doing this workflow like normally, you would have QGIS server on some like personal computer, or sorry, you'd have QGIS desktop on a personal computer, QGIS server running some hosted machine somewhere, and you would have to push your project file every time you wanted to make changes up to that server, and synchronizing all that's a huge pain in the tuchus. So we could just ship it all together, and you don't have to make the change one place and not worry about all that. Already synced. So that's pretty sick. Another thing to know, the keyword list here. These are the tags, metadata tags, that describe what the heck your deployment actually is. And this is what Dragon uses to determine recommended data set. So, pretty cool stuff. Now, there's one other thing, well, really two other things. They kind of build on each other. We talked about the backup GeoCamel DB task in GeoCamel task scheduler, right? So where does that actually live? Where do these backups live? What do they look like? And how's all that actually happening? So to understand database backups in GeoCamel, you have to understand a really important concept, and that is the persistence layer. GeoCamel is mutable, but not persistent. mutable but not persistent. As opposed to what you might be used to, like, oh, it's an immutable desktop experience. No, you could totally like blow stuff up in this, and we're gonna allow it. But if that happens, it's as simple as restarting these containers and going back to a previous state, and it's all gonna happen behind the scenes. You're not gonna have to worry about it. Just restart the service, right? But then if you do that, all of your data, because it's not persistent, goes away, except it lives here. So to reduce the size of these containers running in production, we've minimized the number of mounted volumes in Docker. But we have this one. And what does it actually look like? So this persistence layer is accessible to every single service: GeoCamel Desktop, GeoCamel Server, GeoCamel Task Scheduler, and GeoCamel Postgres running in your deployment. And it contains, by default, DB backups, a directory, a README, so you know yes, and geocamelproject.qgz, which is the actual QGIS file that we opened in GeoCamel Desktop in QGIS, and is also the same project file that's being served by QGIS Server in GeoCamel Server. And finally, GeoCamel Status, which is just a very simple file right now. We're still working on this feature, but it just kind of pings things and tells you if it's up or not. So on the topic of DB backups, let's open up this DB backup directory, and you'll see a lot of backups. I've been working on this project for a while. Who knew? Data comes out all the time. You got to stay up to it. So each one of these is timestamped. They're timestamp directories. If we open like the most recent one, you're going to see a CSV file containing the US states and territories layer that we saw in GeoCamel Postgres, and a CSV file for that world map layer that we saw in GeoCamel. Well, but there's a special thing here, which is geocameldb.tabor. And this is the final piece of the puzzle, that sixth software product that we have under the platform we haven't talked about at all. Here's where it comes in. Tabor is a database modeling language for geospatial data. And what it allows me to do is programmatically and simply create database schemas, database constraints, and feature groups within my database without having to worry about SQL queries. I don't have to do any of that. I just have to write something that kind of looks like YAML, but is a little bit, well, not a little bit, it's a lot more restrictive in its syntax, but syntactically it looks like YAML. You may be noticing, either in the room or at home, there's no syntax highlighting, there's no auto completion for any of this stuff. That's true, obviously we're in Vim, but like in any editor, it would be really cool if somebody made a Tabor extension for just putting it out there for the world. So what is this actually showing you? Well, this is showing a schema definition for every layer, both with geography and non-geographic layers, or just tables in the database, that live in GeoCamelDB. So we've got geography columns, that's just a table. You can see it's got a bunch of fields, mostly text fields and one integer field, geometry columns, spatial referencing system columns, and then here's US states and territories, finally, world map. Sorry?
That number in VI?
Oh, yeah, sorry. There you go. Much better. Okay. So you can see for these two layers at the bottom, well, let's just look at world map as an example, and I'll kind of give it some space since that's the one we're looking at. The world map has these fields associated with it. We can define the data type, we can define the schema that's supposed to live in, who owns that data, but also what geometry that data is. So in this case, it's a multi-polygon layer. If for whatever reason I wanted to define this as like a point layer, you know, all I have to do is change this to point. Or if I was mapping, like, for example, like rivers or roadways or something, that would be like a line feature on a map, right? Drawing a line. I could just call this a polyline feature. So I can define my entire database schema programmatically in a simple, easy to read text-based environment, right? And then the Tabor executable, what it's going to do is it's going to read through this whole dang thing and convert it to a bunch of really ugly, hard to write PostgreSQL queries and load it straight into your database. Then once the schemas are created, we're going to go in and look at those CSV files and just load them into the new schema we created. It will also do database migrations to a point. So if I wanted to change this value, right? So FID is no longer an integer, it's now text. If I wanted to reload that data set, it would drop the column and repopulate with the new data type, which is pretty cool. There's also a bunch of other things it can do. I don't have currently database constraints on this, but I can just show you like repository and our documentation. So let's go to geocamel.com and we'll go to our GitHub. So this is a GeoCamel project, GitHub, GeoCamel, obviously. And we can look at Tabor here, as well as everything else that we just looked at. And you can see an example of what those database constraints actually look like. So for example, we have a layer here called grass, a layer here named trees, and a layer here named streams. So what we could say is that trees have a database constraint here stating that a tree is only a tree if it's, for example. You don't want to have a tree in the middle of a road, right, growing out of the asphalt. I mean, maybe it happens, definitely happens, but for this data set, we don't want to consider that a tree. And what will happen in QGIS Desktop, within GeoCamel Desktop, if I try to add a tree that's not on grass, it's going to give me a complaint. It's going to say, no, you can't do that. It doesn't actually exist. And we've got some other data constraints coming, including features that are near each other within some distance, constraints that say this feature has to be a certain length or square area, things like that. That's all coming in Tabor 0.3.0. So I think I got through everything, and we still have like 5 minutes. I can't believe it. So before we do a Q&A, I want to thank everybody for coming. This is the first time I've ever presented anybody, except for Sean. Because again, I talk about it with Sean all the time. So you can reach out to me. There's my email, Blue Sky, Twitter, X, whatever. Oh, I don't know anymore. GitHub and our website, geocamel.com. If you have ideas for GeoCamel and like what it can do for you, you have a use case for it and you want to chat about that, I'm available for some consulting and educational services. So if you get stuck on something or whatever, we're also, as like a platform, as a project, it's just me right now, really. Sean yells at me and tells me what I need to do, but I'm doing all the work. If somebody had an idea, we got a bunch of open issues, or if you have an issue you want to open, and we would greatly appreciate that. So with all that said, any questions? 5 minutes. Yeah, in the back.
Any plans to migrate it to Kubernetes?
Yeah. Okay. Yeah, that's a good question. So admittedly, right now, it's not very scalable. So yes, that's something we want to do. It's kind of a question about how to do it gracefully. That's going to happen probably at the second major release. So not our main priority, but it's something we want to do. For the use cases that we're talking about right now, kind of aiming for smaller organizations and individuals, they're not always going to need Kubernetes. But as we grow and more people start getting introduced to the project and want to use it for even bigger, more scalable projects, yeah, Kubernetes is on the roadmap. Cool. Anything else? Yes.
Okay, so for smaller groups and individuals, what maybe I'm just coming at it from I built static sites.
Okay.
Why does it need to be running all the time when it's mainly all read-only stuff? Like it seems like this is something just about everything you listed, other than the task scheduler, but most of those tasks were just for maintaining the running stuff. Could be like on a GitHub pages or something, and you could have
yeah.
Could be.
So yeah. So okay, that's a good question. So for those who didn't catch that, like the question was, why are these services running all the time when they're not always doing essentially, right? So they're not always running. So for example, GeoCamel Desktop goes into like a standby mode when nobody is, so it's running, but it's not actually doing anything, right? It just kind of like freezes the state of the application And when somebody connects back into it, it starts it back up. GeoCamel server portal, and GeoCamel server with QGIS server. QGIS server isn't really doing anything either until somebody requests something from it, right? So it's just kind of sitting, waiting all the time for somebody to make a request. And when it finally happens, QGIS server goes, oh my God, I've been waiting for days, and then gives you the data, right? Same thing with QGIS server portal. So we compile everything on QGIS server portal, static sites files. So it's React, which was a huge controversy. We're going to do that. Yeah, so it just compiles everything. It doesn't recompile anything on the fly. If you want to recompile it, you're going to have to rebuild those containers. And that goes for anything. Like, again, we're not mounting the development like source code to these containers. It's fully packaged, and the only way in is through that persistence layer. And none of the source code lives in the persistence layer. So the point taken, GeoCamel Task Scheduler is the most active, but it doesn't necessarily mean that these things are always.
I guess I didn't mean that they're not doing something. I guess I meant that everything that you displayed as in the examples I can think of, like, you'd need to be like, I have this change and I need it to be immediately visible on this voting website.
Oh yeah.
Right now or something like that. But otherwise, it could all be static. But
oh, okay, yeah, I see.
It's running. You don't have to pay for RAM. And QGIS on your own computer is a better experience than using it through, in my experience, than using it over a network running through an external modality.
It could be. You can also connect to the Expert server like natively through an Expert viewer, which does not, it unrestricts all of the things that are restricting it currently in the browser. So you could essentially run it like a native Linux application on any platform that way. There will still be a little bit of latency. Yeah, I mean, I think real-time GIS is really important, and that's something that we want to support. We've always wanted to support it at the project, and that means having data sets that update live as soon as things are done. So you don't have to go through that deployment pattern again just to say, oh my gosh, like I updated my data. Now I have to go through this whole process of upping these containers and whatever. Like you just want it to happen and not think about it. It makes dealing with deployments with a lot of data or deployments with real-time data a lot more easy. So that's really the reason.
Data sets that update like every minute or something.
Yeah, well, they update whenever GeoCamel server gets pinged. When you load GeoCamel server portal, it pings GeoCamel server and QGIS server and says, hey, like, is there anything new that I should show on this page? And GeoCamel server will say, oh yeah, like put this stuff up there. So it's all at like per request basis. I mean, it looks like it's all happening instantaneous, but you still have to. So, okay. I think that's all I got. So let's go have some tea. Thank you all for coming. This was great. Thank you. Good turnout. Anybody here to stop the live stream? I don't. They're running through the hallway right now. Okay. All right. Thanks a lot.